Hi guys, good evening. How are you all? I hope every one of you is doing absolutely fantastic. This is your chemistry expert Sanjay Arya sir, and today we have the second chapter of chemistry from this very amazing series, that is atomic structure. So previously we have finished complete theory as well as 2002 to 2025, 2024 all the PYQs of JEE with mole concept, and now we have come to atomic structure. Let's welcome this chapter, very amazing and very beautiful chapter with a high weightage chapter. Today our target is to cover over 100 plus PYQs from 2002 to 2024. Then we have atomic structure chapter, and we will go topic wise segregated. We will go along with topic wise. So what is the first topic, everyone? Let us come. Knowing about your chemistry expert, my name is Sanjay Arya, completed my BTech from ITSM Dhanbad, over 10 years of experience, and I have mentored over 5 lakh students with these amazing beautiful ranks that I want you people also to participate and produce these kind of beautiful amazing ranks. Now coming to the first topic of this very amazing chapter, atomic structure, we have Bohr's model of an atom. So first of all, let me know, am I properly audible or not? I am absolutely audible and visible, and I'm looking very good. Thank you. So now we have first topic of Bohr's model of an atom, and I'll start solving the first question. There we go. The very first question is in front of you. I hope every one of you can see the question, and if not, I'll dictate the question and you people try to solve this question along with me. Question says that for an hydrogen atom, the energy of an electron in first excited state is 3.4. First excited state. So what is the first excited state? N is equals to, so nth excited state means n plus 1. So this will become 1 plus 1, that is 2. This is your first excited state. Then what is it saying? And it is 3.4 electron volt negative. And kinetic energy of same electron of hydrogen atom is x electron volt. Kinetic energy of same electron of hydrogen atom is this. Okay, so what will be, for energy of second is given, total energy is given to you negative of 3.4 electron volt. So what is it saying? That the kinetic energy for the same hydrogen atom, for the same shell, I guess shell is the same electron, and what is the value of x? This is very easy question, guys. Isn't it very easy question? Isn't it over easy question? Oh, thank you Sachin. So now coming to this amazing question, we have kinetic energy. The kinetic energy will be a positive of total energy, nothing more than 3.4 electron volt, and 3.4 volt in terms of 10 to the power minus 1 can also be written as 34 into 10 to the power minus 1. So your correct answer should be 34. Now you please check it out. Absolutely correct. So guys, that's how we do. So that's how we do. Next question is, the value of Rydberg's constant RH is 2.18 into 10 to the power 18 joule. I guess this should be minus 18 joule. Yes, it is minus 18 joule. The velocity of the electron having mass 9.1 10 to the power minus 31 kg in Bohr's first orbit. Guys, these kind of questions are very easy questions, okay? They look like very difficult, but they are literally not. What is the meaning of RH? Rydberg's constant gives us the value of hydrogen with the first shell. So hydrogen, an electron in hydrogen with its first shell will be having RH, and the unit is a very important part, joule. That means this is nothing but the energy of hydrogen atom, or this is the electron in first shell. This is given to you 2.18 into 10 to the power minus 18 joule, and we also know that this is the amount of energy which is also called as the kinetic energy, because we all know that kinetic energy and total energy for an electron in its nth shell are exactly equal. So keeping this thing in our mind, we'll be having the value of kinetic energy as half m. What is the m for an electron? This is 9.1 into 10 to the power minus 31 kilogram into v square must be equals to this RH, which is nothing but the energy of hydrogen first shell, that is 2.18 and 10 to the power minus 18. You people have this equation. You people are mathematicians. You chose mathematics as one of your subject, and I totally trust you people. I know you can find out the velocity from here, but do not undergo any kind of shortcut using this formula, because it is asking you the nearest integer. It's very important that you solve the question last till the last and then come to the final value. Then only you can go for the nearest integer. Do not try to solve anything with any shortcut till here until or unless the options are given, because if options are given, A, B, C, D options are given, then you can pick either of the option according to your senses and nearby rough calculation. But using rough calculation can lead you to incorrect answer in these cases where integer type questions have been asked. My suggestion is you better solve it. And then let's see how much the answer comes. It will come up as 21.88 into 10 to the power 5 meter per second. So velocity will come up as, this velocity on solving will come at 21.88 into 10 to the power 5 meter second inverse. That's it. That was our second question of the day. Hopefully you all have gone through it. Hopefully you all know about it. We have third question of the day. Here is the third question. See, what does this question say? Hard worker, hi. So hard worker, please try to solve this question. I guess it will require some hard work of yours. JEE Main 2014 10th April evening shift, this question was asked. And I have seen this part, everyone. I'm sharing this feedback with every one of you. I saw the paper of 2024 and I found plenty of questions came from this chapter, which is your atomic structure. I also went to one of the chapter called as mole concept, which was our previous chapter, but not so many questions were there in 2024 or in 23 or like recent days. Maybe there's a mixed concept of mole concept used in entire paper, but not specifically on the mole concept. Here we have plenty of questions which are directly being asked on the formula. So there we have another question. Everyone, please try to look at this question. You are providing an electron. Oh, I don't know what is this happening. Okay, we are providing an electron some energy. This energy is 1.47 10 to the power minus 17 joule. So that an electron from its nth state gets excited to n plus 1 this state, and using the radiation of this energy which is given over here, the value of n should be what? This is not so easy question, frankly speaking, because this question require a proper equation forming, and I can give you the idea. So how we can do this question? We have to find out the delta E value. So this delta E will be, I remember the formula, by the way. If we talk about the 2.18 into 10 to the power minus 18, ये आ रही है? पारा क्या हो गया ये? Sir, am I audible now? Hopefully. So let's carry on, guys. Now let's continue, everyone. Now we have reached there. Okay, no voice. I'm sorry, guys. JEE AR1. Hi, guys. Hi. Am I audible? Yes, I am pretty much. Hi, guys. Hi. Am I audible? Yes, I am pretty much. Okay, thank you, guys. Thank you, JEE AR1. Thank you, sir. So now we will come back to our ongoing question. And let me just explain this question again. Just a simple, quick recap of this question. The question says that some photon of this much amount of energy striking to an electron from nth state and leading it to n+1 state. It's a transition from lower to higher. This amount of energy is 1.47 10 to the power minus 17 joule. We use the formula that energy is equals to, either use it minus 13.6 electron volt z square by n square 1 by n1 square, sorry, z square 1 by n1 square minus 1 by n2 square, or use in terms of joules. RH is already given, 2.18 10 to the minus 18 into z square 1 by n1 square minus 1 by n2 square. We use the formula, we try to find out the value, which nearly came up as 3 by 4, and the value suggested was 1. That is how you can do this question by your own. Now let us come back to the next question. Everybody, please try to solve this question. And JAR1, hopefully you people are right now pretty much able to solve the questions. Now let us come back to this JEE Main 2024 13th April morning shift. We have this question saying that energy of an electron in the first Bohr orbit of hydrogen atom is negative of 2.18 into 10 to the power minus 18 joule. Its energy in third Bohr orbit will be what? So we already have the value of first Bohr orbit, and in third will be what? It's very easy, guys, because energy is equals to this RH, or which is called as the energy of hydrogen in first shell, multiplied by z square by n square. Right now we are talking about third shell, so E n is equals to 3 will be directly proportional to, or we can say will be simply equals to, energy of first divided by n square will be 3 raised to power 2. So it will be 1/9 times of the energy of the given value, and it will C be the correct answer. I don't understand like why so many easy questions, these kind of so many extra easy questions have been asked in order to just raise the unnecessarily the competition value, and probably all of you might be able to solve this question. This was so much easy question. Even somebody who has only applied in CRT rather than going for in-depth preparations of everything can easily tackle this question. Anyways, we are now fit and fine to reach to the next question. There we go. Correct. The answer given is C. Not a good question to me. I have done so many good questions till here, so not a very great question as such. We have next question with us, everybody. We have the next question. The question is pretty simple, saying that according to Bohr's model of hydrogen atom, the angular momentum of an electron is given by its stationary state is quantized, which is absolutely true, which is also equals to MBR is equals to NH upon 2 pi. So this N is representing some integral values, and that represents the quantized nature of angular momentum. We have the statement second, the concept of electron in Bohr's orbit violates the Heisenberg's uncertainty principle, which is also a correct statement, I guess so. The concept of electron in Bohr's orbit violate the Heisenberg's uncertainty principle. Why is it so? Because in Bohr's orbit we were pretty much able to find out the velocity and position very accurately by measuring the distance. R is equals to 0.529 square by z, and velocity is equals to 2.18 10 to the power 6 z by n. I guess first is correct, second should be incorrect. Let us see whether first is correct, second is incorrect is where. I guess B is the correct answer. So my answer should go with B. Let us see B, and the answer given is C. My bad. Okay, sorry. The second is also correct, no? What we are saying is, this is absolutely violating. This is true, yaar. Where were me? Anyways, the correct answer should be, both are correct, right? C is the correct answer. My bad. C. So which book should I go for physical chemistry? Guys, if you wanna seriously follow some book, my suggestion is that for theory point of view, this whatever I'm teaching you, my notes are highly sufficient, not just for JEE Mains, even for JEE Advanced. You need to follow my notes and try to make my like your own notes in your own terms and your own way, in some simplified manner or in very sequential manner. And you, if you are like 2025 student or 2024 student right now, then 2025 student can also make short notes out of my complete lecture, and then they can start solving the PYQs given over here. So any book you want to go for, and specifically the student who are preparing for JEE 2025, they need to download these all the questions which are given over here. That is completely enough for you. PYQs is the best thing that you people can do right now at this point of time. People who are right now preparing for upcoming exams such as 2026, 2027 and all, they can prepare their physical chemistry by using some of the very good books available in market. Narendra Avasthi is one of the book that you can follow to solve the problems. Another good example could be P. Bahadur is a very good book that you can try. Singage edition books are also good, but do not get too much involved in the theory part. Just simply break out the theory and then try solving the question, because out of these chapters which are typically from physical chemistry, numericals have been asked very consistently. Now I'll move forward. Yeah, Bill, absolutely. 2024 will not gonna happen. My bad. There we have the another question of the day. We have the question saying 2023. Now from 2024 we have come to 2023, because plenty of questions have been asked from Bohr's theory till now. 4 or 5 questions, I guess so. Now we have the another question of the day. The question is pretty simple, saying that JEE Main 2023 question, 25th of Jan, let it be. The radius of the second Bohr orbit of lithium is x, Li2 plus is x. What could be the expected of third Bohr orbit of beryllium? Okay, we'll try and we'll solve it. So guys, we all know that radius is directly proportional to n square by z. So what I can write down over here is the radius of beryllium 3 plus and n is equals to third divided by radius of lithium 2 plus, n is equals to second Bohr orbit, must be equals to n square, n is 3, so 9 divided by, what is z? Beryllium, hydrogen, helium, lithium, beryllium, 4. Then n square, hydrogen, helium, sorry, 2 is given, 2 to the power 2 is 4, and it will become hydrogen, helium, lithium, 3. So don't we have this value with us, and then radius of beryllium 3 plus for n is equals to 3 will be 27 by 16. What is it? Given x, this is your correct answer. Can we have any option? Yes, D is the correct answer, 27 by 16x. So okay, thank you by the way, Vishal, thank you. That was good, man, that was good. We have the next question, everyone of the day. We have the next question. Assume that the radius of first Bohr orbit of hydrogen atom is 0.6 angstrom, and the radius of the third Bohr orbit of helium will be what in terms of picometer. Now these questions are exactly the similar one, the one I solved right now over here. I don't think any of the difference between these two questions right now, but I'll try to solve this question in front of you. In order to gain the confidence, you people should try these questions by your own, not just relying on me. Try these questions by your own. We have assumed the radius of the first Bohr orbit as 0.6. So the radius of helium positive we have to find out for n is equals to third Bohr orbit. Okay, n is equals to 3 divided by radius of what has been given to us, hydrogen atom, and that too of first. is equals to n square by z. They are directly proportional to n square by z. So what is the n square for there? 9. Z is hydrogen, helium 2. N square, what is N11? Right? So what will be the radius of helium plus for n is equals to 3? 0.6 angstrom multiplied by 9 by 2. How much does it come? 2.7, right? 2.7 angstrom. 2.7 angstrom is our correct answer. Okay. Okay, it's asking in picometer, make it in 10 to the power 12. This is what? 10 to the power minus 10 meter. So if you want to make it 20 to the power minus 12, make it 270 to 10 to the power minus 12 meter. Now let us see whether we are on the right side of the question or not. Our answer is coming 270. 270 is the most correct answer, everybody. You people have scored positive 4 marks. Great going. Very nice, Vicky. You have done it. Very nice. Or Muskan Kumari, Maldives. Thank you for such wonderful appreciations you people have raised. Thank you, everyone. Thank you so much. Now we will be coming to the next question. Came in 2022, exactly 2 years back from here. We have the question that identify the incorrect statement out of the following. We have been given with 4 options and we have to find out the correct option. A circular path around the nucleus in which an electron moves is proposed as Bohr's orbit, which is true, correct? An orbital is the one where electron wave function in an atom. I guess this is correct, but we are not having too much of the enough information here. But as per the information given, it is true. Existence of the Bohr orbit is supported by hydrogen spectrum, which was the greatest victory for Bohr's model of an atom, because it's all the calculation matched with the Rydberg's hydrogen spectra calculations, and that made Bohr a very successful atomic model by that time. Atomic orbital is characterized by quantum number n and l only. Oh no, wrong. Orbital we are talking about. In orbital we have n, l and m. M is the magnetic quantum number. Although this question is not directly from the Bohr theory, this belongs somewhere with the quantum number, but this is some incorrect statement I find. False. And I guess only D is the correct answer. How easy these questions are. Vicky, you have made it. Vicky, you are right. Option D. Mallika, you are also right. Very good. Malik Arjun, you are doing it absolutely great. Great. Now let us move to the next question, everybody. The way we are going right now, the speed which we are right now have acquired, it will literally take us around 3 hours hardly to finish all of these questions, which are right now 100 plus in numbers, and this will be a great practice session for all of us. So those who are watching right now, people, please enjoy the session. Try everything using by your own. Just open your notebook and try solving everything by your own, and believe me, you will be very much freely able to solve the questions. And also the people who will be watching this lecture right after this one, not lively, they will also be appreciating it, because this is containing the whole number of PYQs asked from 2002 to 2024. Coming to our next question, which is JEE Main 2022, 27 July morning shift has been asked. Question says that given below are 2 statements. If you are not pretty much able to see what is written over here, I am gonna to give you the notes right from here. All the questions can be downloaded right now. Only go to our Telegram channel. The link is given in the description, and join our Telegram channel where you people will be able to download the notes easily, and then you can practice every question by your own. So don't panic. We have another question, 2022. This question says that, okay, one is assertion, another one is reason. Assertion, reason question is here. Assertion A says that energy of 2s orbital of hydrogen atom is greater than that of 2s orbital of lithium. Okay, now let me check whether energy is directly proportional to z square. Is it? Yes, that is why this statement is true. Isn't it? Absolutely, sir. The energies of the orbital is in the same subshell decreases with the increasing the atomic number. No. What should I say now? Energies in the orbital in the same subshell. Same subshell, if we are talking about, let's say 2s, and it decreases with an increase in the atomic number. I think this is incorrect. What should I say? We do not have any correct answer mentioned over here, because what I have explained to you, that if you are talking about same subshell, let us suppose we are right now talking about 2s subshell, and for 2s, if we are increasing the atomic number z, then the energy should increase, because energy is directly proportional to z square, inversely proportional to n value. So right now what we are increasing is value of z. Energies of the orbital of the same subshell decrease in increasing the atomic number, which is, I guess, incorrect option. So reason is wrong, but assertion is absolutely correct. Correct answer should come up as C, not A, because guys, so C is the correct answer, A is true and R is false. Everybody please try this question once again. You people all have the data with you and everything is given with you. Those whoever are facing any kind of doubt, do let me know in the comment section. I can deal with it. Somewhere I have not mentioned it correctly over here, but the correct answer should be C. Okay, very easy to define, very easy to solve it with. We have the next question, everybody. The longest wavelength of light that can be used for ionization of lithium in ground state is this. Then the value of X is what? How should we start solving this question? Tell me. What should I do? X into 10 to the power minus 8 meter. So longest wavelength, how can we get the longest wavelength? Can be used for ionization. Ground state is this. So guys, if something is in ground state here, n is equals to 1, and if you want to this electron to reach to n is equals to infinity, so what should be the delta E that we have to find out, which is equals to the energy of the photon? I'll try this question. Let's see how do we get the answer. So this value will be, delta E will be coming as, we have to take hydrogen atom ground energy is 2.2. So it will be 2.2 10 to the power minus 18 z square 1 by n1 square is 1 minus 1 by infinity square. This term will become 0 automatically. This will be 2.2 10 to the power minus 18. What is given to us? We have hydrogen, helium, lithium, hydrogen, helium, lithium. So hydrogen, helium, lithium, 3 will be 9, and this will 1 by 1. So in order to, okay, we have to do one more thing here, and that one more thing is comparing it with lambda. So we can do it anyways, we'll try. So anyways, we have got the value somewhere near around 19.8 10 to the power minus 18. 19.10 to the power minus 18 is the value of the energy, which is exactly equals to hc by lambda. So 6.63 10 to the power minus 34, 3 into 10 to the power minus 8, sorry, positive 8 divided by lambda. And I know this value nearby comes up, this value nearly comes up as 2.25 10 to the power it is simply 2 into 10 to the power minus 25 divided by lambda. So guys, you can solve this value and you can get the value. So lambda should come around 7, it will become, no, we have to find out in terms of 8. 10 to the power 8 we have to find out. So what we are finding, by the way, value of x in terms of minus 8. So this is coming minus 7. So minus 8 will make it 20. It will be around So 4 is coming as the answer. But okay, wait. I remember this question was a bonus question, guys. Don't worry, everybody. This question was a bonus question because I remember this question had lithium atom with us, which is incorrect. If it is a lithium atom right now we are having, then definitely it won't work. The formula is only for one electron species, and that's why this concept was it was a bonus question actually. So I would rather skip this question and we'll move forward to the next one. It's a bonus question. Now coming to the next question. Okay, thank you. Oh, that was a great joke I had. I ate something in breakfast. Funny. Come back to this question, everybody. JEE Main 2022, we have 26 June morning shift question with us. Question says that if the radius of third Bohr orbit of hydrogen is R3, then what will be the radius for fourth Bohr orbit? I don't think this is a good question because similar question have been done earlier by us. We know the way that if we are talking about hydrogen only, then we'll simply say that radius is directly proportional to n square. So this will become R4 by R3 will be equals to 4 square, that is 16, and 3 square by 9. So that is why your R4 will be 16 by 9 times of the R3. So don't we have any such option? We have B over here. See how easy was this question, and we already have solved such questions. See, B is the correct answer. So not a great question we had. Another repeated concept was here. So let us have one more question over here. So given are the two statements, I'll dictate all the options over here, and now you people try solving them by your own. Yeah. So according to Bohr's model of an atom, qualitatively the magnitude of velocity of electron increases with decrease in positive charge, and there is no strong hold by the electron by the nucleus. I don't know what is this saying, by the way. Let me just reread it. According to Bohr's model of an atom, qualitatively, the magnitude of velocity, I know the magnitude of velocity is directly proportional. Velocity is always positive. So the velocity is directly proportional to z by n. So if you increase z, decrease in positive charge on the nucleus. No, if you increase z, then it will increase. So with increase in z, this is a false statement. Why is it false statement? It is saying that velocity keeps on decreasing if you increase the positive charge on the nucleus, which is your atomic number z. So this is a false statement. Coming to the next one, we have according to Bohr's model of an atom, qualitatively the magnitude of velocity increases with a decrease in principal quantum number. So if you decrease the shell, then it may increase, and that's what we know. If you're decreasing n value, then overall it will increase. So this is a true statement. Now false to true, just match these two, you'll be getting the correct answer as one is false, another one is true. So C is the correct answer, I guess. Let me check. C, we have C is the correct answer. That was good, Muskan, very good. Keep it up. And Mohammed Star, very good. So there we have the another question, very amazing question from JEE 2021. We had this question asked back in, I don't know which year was it asked. No, this was asked in 2021. We have another question from 2021 asked in 18th March. So guys, apart from this lecture right now, what you are watching, you don't require any further explanation, any further practice sessions. Every single P by Q is right now with you. Just download this and try solving by your own. And that's why I'm giving you. See, wherever I'm solving the question, I'm pretty much writing something, but wherever the solution part is given or the answer part is given, it's completely clean. So you can try solving the question by your own and gain your confidence. Coming to this question asked in JEE Main 2021, we have statement 1. Bohr's theory accounts for the stability and line spectra of Li positive ion. So can you tell me what is Li positive ion? Hydrogen, helium, lithium. No man, no, this is not single electron species. There it has 2 electrons. Hydrogen, helium, lithium. Yeah, it is 2 electrons. So this is a false statement. Number 1, we have Bohr's theory was unable to explain the splitting of spectral line in presence of magnetic field, which is true. And this thing is called as Zeeman effect, which explains that lines which were explained by Bohr get splitted in the external magnetic field, and that thing was not able to be explained by Bohr's theory. Now tell me false and then true. What should you say? False and true. False and true. I think A should be the correct answer. A is correct. Thank you. A is absolutely correct. Muskan, please look at the questions carefully. The questions are pretty simple, but I know that these questions require some typical knowledge and are not that much easy what we think right now are. Which of the following forms of hydrogen emits low energy beta particle? What is it, yaar? I guess the only radioactive one, the only radioactive hydrogen, which is tritium 1T3. A should be the correct answer, I guess. Correct, everyone? A is the correct answer. Thank you. Coming to the next question. I guess that was the most easy question we had till here. Most easy question. And the way we are going and with the speed we are going, it's pretty simple that in coming 3 hours, we'll be finishing whole number of PYQs from 2002 to 2024. We have another question from JEE Main 2021, asked on 24th of February and evening shift. The question says that according to Bohr's theory, kinetic energy is directly proportional to Z square by N square, which is true because energy is equals to 2.18 into the power minus 18 Z square by N square joule per atom. And what I'm saying is it is directly proportional to Z and inversely proportional to N square. Okay. Product of velocity of electron and a principal quantum number is directly proportional to Z square. The product of velocity so velocity is directly proportional to Z by N. So what is it saying? That velocity multiplied by Z, principal quantum number N, sorry, velocity into N will be directly proportional to Z, but it is saying Z is square, so this is false. Then frequency of revolution is directly proportional to Z cube by N. Z, I am not even getting it. What is it written here? Z square by N cube, I guess. No idea. And Coulombic force of attraction of electron is Z cube, and this is also incorrect. Choose the most appropriate answer in the following. Only A. Anyways, what is the correct answer given? Maybe D was the correct answer, which I cannot see from here. So I would like to ask you people to download the notes and then get back to this question, and then you will be able to see the correct answer. And everything is pretty much self-explanatory, doesn't require too much of effort. So don't worry guys, don't panic. Everything over here is written, and I have explained every single part of Bohr theory in my theory sessions of previous lecture. That was your atomic structure, complete theory. We'll simply come up with the next question. There we have the next question, everybody. The question says that the difference of the radii of third and fourth of Li is R1, and that of third and fourth for helium is delta R2. Man, why are they wasting our time? Unnecessary questions have been asked. But anyways, I can make you sure of one thing only, that if you want to find the delta R, you all know that radius is directly proportional to N square by Z. And N square is exactly the same that we are right now having. So, it's directly proportional to 1 by Z. Just simply put this thing in your mind. So, what we are going to find out with? Li2 plus and then for He plus. So, delta R for Li2 plus lithium upon delta R of He plus will be equals to, so there will be hydrogen helium lithium 1 by 3 into 1 by hydrogen helium 2. I think 2:3 should be the correct answer, C. So wasn't it a very easy question? Yes, it was, sir. So guys, C is the correct answer. And now, so we are right now moving with very good pace, very good speed, and everything is going very easy with us. Everything is absolutely easy right now what we are having. And C was the perfect answer you all picked. We have a question from JEE Main 2020, which is saying that the de Broglie wavelength of an electron in Bohr, fourth Bohr orbit will be what? De Broglie wavelength, okay. And I have no clue what is A naught. I literally have no clue what is A naught. But anyways, we can try this question. I know that MVR is equals to NH upon 2 pi. So 2 pi R is equals to NH upon NB. H upon MV is lambda. So 2 pi R is equals to N lambda. And what we have to find out is de Broglie wavelength of fourth. So 4 will equals to 2 pi R by 4. So now I have no clue what A naught is. I don't know how to get with this question ahead. But in terms of A naught, if A naught, okay, A naught is the radius, I guess. So okay, let me recall this concept. So this A naught is actually the radius for n is equals to 4, isn't it? No. This is for n is equals to 1. A naught is equals to R for hydrogen, n is equals to 1. So a radius for hydrogen, n is equals to 4 will be what? 4 square into A naught. Now put you this value, and lambda of n is equals to 4 will be 2 pi by 4, and this will be 16 A naught. So this is 4 into 2, 8 pi A naught. Do we have any such answer, 8 pi A naught? So C is the correct answer as per me. Now you people are pretty much watching this lecture. You people should also be very sure what to pick, what not to pick, and how to pick. We have C as the correct answer, and Muskan, very good, very great. We are like, I can see that few of the students of, among you are doing it very dedicatedly, trying to solve every single question. And believe me guys, you people are the one who are gonna to qualify not just JEE Main, also JEE Advanced, because this kind of dedication is something that is required at initial point of your time. And once you have generated an interest in your subject, nobody can stop you, that's my promise. Nobody literally means nobody. Great going. Next question from JEE Main 2020. Please try this question, JEE Main 2020. And those who haven't liked the session till now, those who haven't liked the session, do like the session right now. Hit the like button, everybody. The radius of second Bohr orbit in terms of Bohr atomic radius A naught in Li2+ is what? Is it a question or it's just a joke to us? Oh my God. So the radius of second Bohr orbit, no? So Bohr's radius means, guys, this is the radius of hydrogen for n is equals to 1, and it is given to us A naught. And we have to find out for lithium. So Li2+ will be what? And n is been given to us second. So how do we get the value? It's like z square by n, n square by z. So 2 to the square upon hydrogen, helium, lithium 3 into A naught. Now tell me the correct answer, everybody. C is the correct answer, I guess. C. Isn't it? C? No. How come C? 4 by 9 is not the correct answer. 4 by 3 is the correct answer. D is the correct answer. D is the perfect answer, everybody. D is the most perfect and suitable answer we had. And that's how we finish these beautiful topics, literally one by one. Hopefully you all are enjoying the session. And even if you are not enjoying, it's not about just enjoyment. It's all about how much efficient and how much dedicated you are about your work. So this might be an enjoyment to everybody, or like a few of the people who literally belong to chemistry. They just love chemistry. It might be a very interesting topic to them, and it's a very easy scoring topic, I found. But the one which we are like not having too much of the interest, it is completely natural. Don't be so much panic. Just start taking the dedications, not just the full interest of it, because sometimes it cannot be like, it might not be that much interesting, but it is actually very helpful to us and beneficial to us in terms of scoring the marks. So always think twice that whatever you are studying is right now, and it is gonna to give you the output right after some few years or some months, and for somebody it is like few days only, those who are right now are preparing for JEE Main 2025. Coming to the next question, we have a question that was asked back in 2018. The question was asked on 15th April morning shift. The de Broglie wavelength of electron present in first Bohr orbit will be what? Now tell me the correct answer, everybody. I guess this is not even a the question we are now gonna to solve. We literally have solved so many good questions. The concepts which we are right now having are very vast. This question doesn't stand in our way. We will simply go, we'll put this value, and just a moment back I taught you this topic. 2 pi r is equals to n lambda, where n represents the shell and it's saying 1. So this lambda will be equals to what? 2 pi r, and this r is what? 0.529 n square by z, where n is 1, z is 1, so simply 0.259 angstrom. So 2 pi into 0.529 angstrom. B is the correct answer. I told you that this question even doesn't even stand in our way. It's like most easy questions till now we have been taught about. So guys, this question which has been asked in JEE Main 2017, and it's an offline question. Why is it an offline question? Because I remember by that time online exams were not being conducted that much up to that much extent, but I remember like offline and online both exams used to happen by that time. So we have the radius of the second Bohr orbit of hydrogen is what? Very simple question here. So the formula of radius is r n is equals to 2 is 0.529 n square by z angstrom. 0.529 into n. What is the value of n here? Second Bohr orbit, 2 square. Hydrogen we have to find out, just put it 1. So 4 multiplied by this will be what? 4, 36, 3, 4, 3, 8, 3, 11, 1 बन जे 20 और 1 21. So it is like 2.166 angstrom. Nearest answer is B. Actually, I was not even about to solve this whole, because see, it's pretty much clear that 4 into 0.5 will be 2, and only correct answer nearby to 2 is B. So this thing can also help you finding the correct outcome. We have Krishan Kumar Yadav submitted the correct answer with us. Muskan, and very good. Keep it up. Another question that was asked in JEE Main 2015, and JEE Main 2015 offline this question was asked. I remember by that time online exams were not being conducted. The question simply says that which of the following is the energy of a possible excited state of hydrogen. First of all, I must know what is it asking exactly. So the question which has been asked is simply saying the energy of an excited state. So if it is an excited state, then n can be 2, 3, 4. N cannot be equals to 1, because n equals to 1 is the ground state. Only excited state could be 2, 3, 4, 5 like that. Now coming to the value of E2, I remember the old values here. I told you once, like if you people remember, and if you even not, then come back to this topic. I remember that even the energy of first state used to be minus 13.6 electron volt, minus 3.2 electron volt, minus 1.85 electron volt, minus 1.5 electron volt, minus 0.85 electron volt, and so on. Now tell me, correct match, the only thing, B is the correct answer. It could be like 3.2 or 3.4, I guess, no? 3.4 electron volt. The correct answer should be E2. The only correct value of the nth shell could be this, not apart from these values. And we all know that this is the quantized model of an atom that was proposed by Bohr, that radius, energy, momentum, what we talk about, their properties of an electron in the atom is always quantized in nature. It can have the values of some discrete values, not just regular values. Then we have a question that was asked in AIEEE exam it used to happen by that time, all India engineering entrance exam. And I remember this exam. This exam was like, it doesn't happen these days, but this exam was conducted by that time, and all the NITs and IIITs colleges were picked by this particular exam, AIEEE. So this question was asked in AIEEE 2010. The question says that ionization enthalpy of helium positive is this much joule per atom. Then the energy of first excited state will be what? What is this? A joke or to what to us? Ionization is this, then the first stationary state. So guys, I remember the formula. If you want to use this formula with me, you can choose this formula, that ionization enthalpy, E of ionization is exactly equals to 2.18 into 10 to the power minus 18 and 1 by n square. Sorry, this will become into z square. So into z square. And how much is this z, by the way? Hydrogen, helium, 4. Anyways, we don't need this formula. So the energy of first stationary state. So first of all, the ionization enthalpy of helium plus is equals to 19.6 into 10 to the power minus 18, which is equals to the RH value or the energy of hydrogen atom in its first state multiplied by Z square. So Z square is exactly 4, and that's how we'll be getting the value of RH from here. 19.6 divided by 4 will be how much? 4 4s are. So this will become 4.4 into 10 to the power minus 18 joule. This is the value of RH, the energy of hydrogen first orbit, whatever it is saying according to that. Then the energy of first stationary state of lithium will be what? So energy of lithium, Li2 plus hydrogen, helium, lithium, N is equals to first will be equals to negative of RH into Z square. So hydrogen, helium, lithium, 3. 4.4 into 9 into 10 to the power minus 18. So I don't know what the value will come up, but it is approximately 4.5 10 to the power. Let's say I'm taking 9 as 10, then it will become minus 17 joule per atom. My guess is actually answer B, and I'm not so sure, so I'll have to check the correct answer. But believe me, there are some very dedicated students today with me, and I am pretty amazed. I am pretty much, what should I say, surprised now, and pretty much happy with these students that these people are doing this very fantastically. And Muskan Kumari and Krishan Yadav, you are among them. Very good guys, very great energy, and keep this thing up. Keep your motivation up. Never let your motivation down. B is the correct answer as usual. So whenever I come and solve the question, it's always a very easy thing to me. But similar confidence I want in all of my students, so that you people can also do the same thing and also can crack the exam of IIT or like JEE Main and Advanced as your teacher did at one time. We have next question asked in AIEEE 2006, which is an offline exam, and according to the Bohr theory, the angular momentum in 5th, I guess this is the most easy question of the day. It is gonna to be the most easy question of the day, because angular momentum is mvr, and according to Bohr theory, it was equals to integral multiple of h upon 2 pi, where n represents the state, energy state, 5th energy state we are talking about. So it will become phi h upon 2 pi. So it will be like 2.5 h cross, or 2.5 h by pi. Oh yeah, 2.5, no, B. Oh, B is correct. B is correct, everybody. Keep your motivation up. And there we have next question with us. The next question is simple. AIEEE 2002. The question was asked in AIEEE 2002. It's an offline question. in a hydrogen atom, if the energy of electron in ground state is this, then that in second excited state will be what? Wherever it is written like nth excited state, that means n is equals to n plus 1. So the energy state will be n plus 1. That is second plus 1 will be equals to third state we are talking about. So guys, for third, the energy is directly proportional to 1 by n square and directly proportional to z square. So energy of hydrogen in n is equals to 3 will be minus 13.6 divided by 9. I guess, how much does it come by the way? Second excited state. It must come up as minus 1.51 electron volt. A is the correct answer, not? A is the correct answer. A was the correct answer right from here. Now we have come to the next topic of the day, everybody. We have the next topic with us right after finishing Bohr atomic model. We have come to hydrogen emission spectra, another very important topic. So let's start. The first question, the very first question from this, we have JEE Main 2024 question. So many questions came in JEE 2024 specifically related to your atomic structure and these particular topics. First question says that the wave number of the radiation having 5800 angstrom wavelength is this. This is a question or it's a joke? So lambda is being given to you and lambda is 5800 angstrom. What you are gonna to calculate is wave number nu bar. Nu bar is 1 by lambda, which will be equals to 1 upon 5800. This value sums up as whatever the answer comes, just find it and find it in the terms of centimeter inverse. Okay, so in centimeter inverse you are going to find out. Okay. What I can do is 5800 10 to the power minus 10. So I can simply write it like 10 by 5.8 into 10 to the power. This is in meter, right? 7. So first I made it like this. 1, 2, 3, 7, and then 8. Minus 8. I can make it 10,000 by 5.8 into 10 to the power wavelength is given and we got to find it out, no? Minus 7 it will become, maybe about 6 it will become. So anyways, I'm directly jumping to the conclusion that you people solve this value. So this is somewhere which is written in meter inverse. This value is in meter inverse now. So what I have to give is the centimeter inverse. So how something can be converted to centimeter inverse is per meter multiplied by 10. So 1 by 500 into 10 to the power minus 8. This has come centimeter inverse. So just find out into 10 centimeters you have to make it. So what I'm gonna to do, I'll make it 10,000. Okay, 10,000 by 5.8 into 10 to the power. Then into 10 centimeter. So this is how it will become. So this is something that we have to find out. And I know it is near to 2000, but if it is asking us integral value, then you got to solve it Solve it till last, and then only you'll get the correct value. You have to solve this thing exactly properly, and I guess then you will be getting some value around less than 2000. Less than 2000 you'll be getting. Your value will be lesser than 2000. So lesser than 2000 is the correct answer, 1724. Although don't ask me to solve the numerical part or the mathematical part, because I know that you people are absolutely comfortable into. You people have chosen this very amazing subject and mathematics with you. So hopefully this is pretty easy for you people to pick up. We have the next question, everybody. Let's welcome the next question we have. Asked in JEE main itself, the number of spectral line has been asked in helium He positive spectra when an electron makes a transition from fifth excited state. You know what the meaning of fifth excited state? N is equals to 6, and coming to N is equals to first excited state means N equals to 1. So total number of lines has been asked, I guess. So try this formula. Number of spectral line is equals to delta N into delta N plus 1 divided by 2. How much is delta N? 6 minus 1. No, 6 minus 1. This is first excited state. So it is N equals to 2. So 6 minus 2 into 6 minus 2 plus 1 upon 2. 4 into 5, 20 by 2. Is the answer 10? Can I see? Can I check the answer 10? Well, great. That was pretty easy and kind of very easy question to us. Another very easy question for all of us. The previous question is done. 10 is the correct answer. Let us come to the next question. The question is another very easy question, and it's saying that there's a list one which is saying we are having some spectra line of hydrogen and the region has to be given. Lyman series, we know ultraviolet. Balmer, visible. Where is visible? Paschen, bracket, Fund, Humphrey all comes up with infrared region. So Paschen goes to infrared. What is wrong with here? Yeah, this can go to anywhere, right? So just match first with second, and first with second and second with 4. Second and 4. I think A is the correct answer. Just using these two information we can get the answer, because rest of the things given to us are not submitting us the correct options here. So I would go for just simple A. By simply opting what is given to me, I have made this question, and that's how smart we all should be. So apply your mind smartly, reach to your destination smartly, rather than going for everything and then just unnecessarily reaching to the same point. Okay. Another question is here. The question is pretty simple, and the question is actually asking us that if wavelength of first line of Paschen series of hydrogen is 720 nanometer, then the wavelength of second line of this series is what? Very simple, yeah. So see, what you are now given up with, 1 by lambda is equals to RH into. So first line of Paschen series given to us. First line of Paschen series is what, by the way? First line. Paschen series has N1 is equals to, they are following to Lyman, Balmer, Paschen 3. And N2 could be, first line could be 4, 5, 6 like that. So RH into something is given to us, 1 by N1 square minus 1 by N2 square. This has been given to us, okay? This is the first line we are now talking about. Using this data, what we can find out is the value of RH somewhere. How much is the value of RH are we getting right now? So 16 into 9. 16 minus 9 is how much? 7. Into 1 by lambda, 1 by 720. Now we'll apply this value to find out the value of 1 by, this is your first line. Then we have 1 by lambda for second line, which will be RH value is already known to us. 1 by, this will be 9 only, minus 1 by 25. Solve this equation and you will get the value. So your RH is already known to you, 16 into 9 by 7 into 1 by 720 into 25 by 9. And what is 25 minus 9 is 16. People, everybody please try solving this equation and then you will get your value. And this is actually 1 by lambda, so try to finding the lambda by just reversing this equation. So lambda will be equal to 25 into 9 into 7 into 720 divided by 16 into 9 into 16. That's how you'll get the value. Let me see what's the correct answer. 492 nanometer you'll be getting as the answer. Right after solving this value, this will be coming up as 492 nanometer. So one of the very easy question was here, and then right after this we have one more beautiful question. Everybody please welcome this question. Let's welcome this question. We have this question, that shortest wavelength of hydrogen atom in Lyman series is lambda. Then what is the longest wavelength of Bohr series in helium positive? See, the questions are pretty simple and pretty much based upon the conceptual mathematical formula that we had. Shortest wavelength. What is the meaning of shortest wavelength? So longest energy. So lambda is actually defined for 1 by lambda is exactly RH Z square. How much is Z? Hydrogen 1 square, Z square, 1 by lambda 1 square minus 1 by Lyman Bohr partition. Bohr is 2. This will be like infinity. So we have got the value of RH here, which is 1 by lambda. So now if I have to apply the same thing for the which line? Longest wavelength of helium plus. So 1 by lambda here, He positive. This will also be the same RH 1 by, okay, RH into Z square, 2 square, 1 by n, 1 by 2 square, 1 by infinity square. This will be 0, as this was 0. The 4 is cancelled out. I think, what should I say here? The longest wavelength in Bohr series of helium plus. So helium is H square. Bohr, it will be coming from infinity to n equals to 2. From infinity to n equals to 2, it will be come up with. I don't know what should be the correct answer. I think it should be the lambda itself. See, on solving, though, it's coming like that only. No. Wait. Longest wavelength, guys. Longest means this should be 3. Smallest energy, 3 square. Now you'll get the correct answer, everybody. So this will be 1 by lambda star will be equals to, this is the RH is already given 1 by lambda into 4 into, this is given to you 36 and this is 5. So the lambda star will be coming up as 36 by 20. Lambda is the correct answer. 36 by 20. What's the value of 36 by 20? I guess this is 9 by 5 lambda. C. So C is the perfect answer that we people were looking for. We have got our answer C. Now jumping to the next question. C is correct. Which transition in the hydrogen spectra will have the same wavelength as Bohr type transition from n equals to 4 to 2 and that of helium spectrum? Well. For the same, lambda should be the same. Lambda is exactly equals to RH into Z square into 1 by N1 square minus N2 square. Now make this values equal for these two options, hydrogen to Bohr. Hydrogen to Bohr. So what is this? We have RH. Let's say if we are talking about helium, so Bohr in helium. No, wait. Hydrogen spectrum would be the same wavelength as Bohr type of helium. So 2 square 1 by this is 4 minus 1 by 16. This should be equals to RH 1 square 1 by N1 by N2, 1 by N1 square minus N2 square, and that is for hydrogen. So now you just equate these two things and you will get your value. By the way, how much does it come? How much does this come, by the way? This will be like 16, then 4 minus 1, 3 by 16 into 4. So this is coming 3 by 4, it must come up with 3 by 4. So we have to make it 3 by 4. So what should be 1 by N1 square minus 1 by N2 square. So how can we get the value 3 by 4 if we are getting 1 to 2? So either 2 to 1 is the correct answer, B is the correct answer in that way. Am I right here, everybody? I guess B is the correct answer. And Muskar and Devendra Bhati, you have submitted me the correct answer. Great, guys, keep it up. I guess that's a correct question. That is correct, actually, absolutely correct. We got. Now we have the another question, which is again a very similar question to everybody. That when the excited electron of an hydrogen atom jumps from n equals to 5 and drops to the ground state, how many maximum lines? We are now tired of these simple questions. The formula simply says that the number of lines will be equals to delta n multiplied by delta n plus 1 divided by 2. Delta n will be how much? 5 minus 1. 5 minus 1 plus 1 divided by 2. It will come up as 20 by 2. The correct answer should be 10. Is the 10 correct answer here? Oh yes, absolutely no. Well, I don't know. What is the correct answer? So anyways, pick the 10 as the correct answer here. Why is not written any answer here? Oh, 10 is correct. Maybe like one more page was given here. 10 is absolutely fit. So hopefully you all are enjoying this session. And even if not, people, please like the session so that this kind of motivation we get, this will definitely help your teachers to get and stay motivated until the end of this lecture. I must appreciate all of you and your efforts that you people are solving these questions with me. But on an equal end, you also must appreciate your teachers which are applying the whole 100% effort for you. Now coming to the next question we have. JEE Main 2022 on 25th of July, this question was asked. The question says, when the excited electron of an hydrogen atom drops, we have completed this question. Yeah? Why are we coming back to the same question? Okay, next question is the region in which electromagnetic spectrum where the Bohr series lines are appear is all the lines which are appearing or which are produced by transition of an electron from n equals to whatever to n equals to 2, which comes under Bohr series, are visible line, and these lines are the Bohr actually. So visible is the correct answer, C. Now what should I do? These are pretty easy questions. Now I'll take you to the next question from here. The shortest wavelength of hydrogen in Lyman is lambda 1. The longest wavelength in Bohr is of helium is what? Isn't it a similar question that we did a few? Anyways, but we can redo this question. Shortest wavelength means the highest energy, and the highest energy comes up with the shortest. We have lambda. So 1 by lambda is equals to RH. This is lambda 1. RH into 1 by n1 square minus 1 by n2 square. This will be infinity. So I guess R1 upon RH, or like it's simply that RH is equals to 1 by lambda 1. Then we have the longest wavelength in Bohr, and that for helium will be N2 is equals to 3 to N1 is equals to 2. And why is it the longest wavelength? Because the energy should be the minimum, and these two shells should be quite nearby to each other, most near to each other. Then we will be having the formula 1 by lambda 2 will be equals to RH into Z. How much is the Z? 2 square, 1 by N1 square minus 1 by N2 square. Solve this and you will get your answer. 1 by lambda 2 is equals to, this RH is 1 by lambda 1 into 4 into, this is 9 minus 4, 5 by 36. So now you can solve this and you can get the value of lambda 2 is equals to, reverse this, 9 by 5 lambda 1. D. D is the correct answer. D is the correct one. Next question asked in JEE Main 2020. For the Bohr series, the spectrum of hydrogen atom, this is like this. The correct statement from 1 to 4 will be what? As the wavelength decreases, the lines in the series converge. You know what is the meaning of line converge? Lambda decreases, energy increases, I guess, right? As the wavelength decrease, I think the energy should increase. No idea on this. What we have to tell, by the way? The correct statements, right? Correct statement. As the wavelength decreases, the line in the series converge. Lambda decreases. So see, lambda decreases, energy increases, and if the energy increases, the energy gap will be smaller. I guess this happens, but not sure. We'll move to the second one first. Integer n1 is equals to 2. For Bohr series, we have n1 is equals to 2, and n2 could be 3, 4, 5, because it's an emission spectra. So all of the n2 values will be higher than n1, and it could be anything. No, very good. Hi, Suryansh Thakur. Welcome. And even all one security. That's good. So now everybody is watching us. Great. We have the next question. So this statement is true. We have another statement with us that says that the lines of longest wavelength corresponds to, if the wavelength is the longest, the energy should be the least. And this is also true. Just right next to the n equals to 2 is n equals to 3. Then the ionization energy of hydrogen can be calculated from wave number of these lines. The ionization energy of hydrogen can be no, we cannot, because from n is equals to 2 to n is equals to infinity, this is what we can find out. This is called as separation energy. But from n is equals to 1, we cannot find out this value. How can we find out this value? Tell me. Or even if we can find out, so none of the option is matching our requirement, because our second and third are correct. So if second and third are correct, second, third and fourth is also correct, right? So A can be one of the option, but first is something that I am not sure of. And what if first is also correct? Okay, let's see what is the correct answer. What we are waiting for? We can check the correct answer. Okay, B is given as the correct answer. So I guess I was right that ionization enthalpy of hydrogen can be calculated from, I'm saying yes, we can calculate it, because using this data, what you can find out is RH, and then this will become what? Simply RH into Z square. All of them are correct, I guess. First, second and 3 are correct. Can be calculated. I don't know, man. So it's a typical theoretical question. Just try, apply your concept by your own. This question is making me a bit sick. I think we should move forward. Too much of theory was written there. Too much was there to read out. I skipped it. We'll reach to our next question. JEE Main 2019, 10th April evening shift. We'll take now questions more seriously. The question simply says that the ratio of the shortest wavelength of two spectral lines is found to be nearly 9. Then the spectral lines are, the ratio of the shortest wavelength. So shortest wavelength with highest energy. So this will become from 9. So this is, let's say, 1 by lambda 1 upon 1 by lambda 2, and this is equals to RH into Z square 1 by N1 square. How much is N1? That we have to find out. 1 by N1 square minus 1 by infinity square. This is also RH1 square 1 by N1 dash square minus infinity square. So guys, this will be cancelled out. This will become lambda 2 by lambda 1, which is given up as 9, and this also has become what? N1 dash square upon N1 square. So that's why N1 dash by N1 should be equals to 3. So where you can get this data of 3? So partition to fund, partition is Lyman-Balmer partition, Lyman-Balmer partition bracket fund. So no, this is not correct. So like choose partition is N1 equals to 3, N1 equals to 1. This is correct. I guess C is the correct option. C is the perfect option that we can pick. Okay, thank you guys, thank you. I hope you all are now understanding the concept pretty well, and keep your motivation up with me, and we will reach to the milestone very soon. And our milestone is to complete this chapter, which is a beautiful chapter, as soon as possible, with all the concept clarification and along with this solving all PYQs which right now are given. We have a question that was asked back in JEE Main 2019 here. The question is again very simple. This says that heat treatment of a muscular pain involves radiations of the wavelength around 900 nanometer, and which spectra line does it be suitable for? Even I don't know, I have to check it. So this lambda is increasing, okay? So ultraviolet, visible, infrared. So first of all, this is going to infrared because it is going beyond 750. So lambda above 750 is like beyond visible, it will be coming under infrared. So whatever Lyman and Balmer are there, just cut them, only take these two. Okay, so there is a shortcut we can do. Instead of finding it for B, let us try to find it for C. Let us try to find it for C, and if C is the correct answer, then C will be the correct answer. If not, then B will be the correct answer. Are you guys ready for this initiative I'm gonna to take? So let us say infinity to 3. Anyways, we can try it. So 1 by lambda is equals to RH is what? 10 to the power 5 into 1 by N1 square. N1 is 9 and 1 by infinity. and this is for hydrogen only, I guess. Hydrogen only. So lambda comes up as 1 by 9 into 10 to the power 5 minus 5. So 1 by 9 into 10 to the power minus 5. So I can write it 10 by 9 into 10 to the power minus 6. So in terms of nanometer, this will be roughly equals to 1000 upon 9 into 10 to the power minus 9 meter. See, isn't it? No. 10,000 by 9. I think C is correct because this will roughly come as 9. No, not like 9. So 1. C is correct actually. Are we getting a value 900 from here? That's a question, by the way. It's actually, I oppositely wrote it down. So it is like 9 into 10 to the power minus 5. And this is roughly equals to, this is in meters. Not in meter, it's in centimeter. So we can make it 900 into 10 to the power minus 9 meters, which is nanometer. So 9, I think this is correct. So we just randomly tried it. We had few options with us, and an amazing option that we had was option number B and C, because A and D were already eliminated out. This question we used some concept called as option elimination method, which is very beneficial. This option elimination method is specifically used in match the column part, where using a few of the information we can abstract the correct answer out of it. But right over here was a very beautiful part that was given to us, that out of B and C there was one option correct. We picked C because C is easy to solve up with, because one of the component will become 0, 1 by infinity square. And now solving this option, we got the correct answer, whatever mentioned in the question, and we picked C as the correct answer. In case if C was not the correct answer, definitely B was the correct answer, because we already had eliminated A and D. That's how we do. Next question coming with JEE Main 2019. This question was asked, and it was asked in morning shift. The question says that for emission line of atomic hydrogen, the initial N1 is 8 and then final is N. The plot of wave number against this. I don't know what's asking, man. What is it asking? For plot of the emission line of atomic spectra, wave number nu bar. So 1 by lambda. Well, this is how it look like, that 1 by lambda is equals to RH into 1 by lambda 1 square, 1 by N1 square minus 1 by N2 square. But this RH, right? So if we are fixing one of the value, if this is fixed, then it will become what? 1 by lambda is equals to, which is nu bar actually. Nu bar is equals to against 1 by N2 square. So this is something constant, that RH into upon 64 minus RH upon N2 square. So it's a linear equation. Y is equals to C minus mx. Can you try this equation? Y is equals to C minus mx. Now check out the correct answer, everybody. C, linear with slope of RH. Emission line of hydrogen spectra from this to this. Wave number is found with this. The Rydberg constant is RH with the wave number as unit. I don't know. It's linear, but slope, I remember that, I guess intercept is not RH. Intercept is RH by 64. First of very all. My bad. Actually, see, this is how it look like. So this will be an initial from this So initial will be, final it is n, and it's emission spectra, so it is coming from 8. So this will be your n2, and this is actually your n1, because finally it is coming to lower one. So this will be becoming n square minus 64, and then this whole equation has a twist here. The whole equation has a twist of nu bar is equals to RH upon n square minus RH by 64. So this is your y is equals to mx minus c. So guys, this intercept is negative RH by 64. So this is incorrect. This is non-linear is incorrect. Linear with slope, this is correct. Now RH is your slope here, positive slope. Can you check this thing? Hopefully all of you are getting my point. Hopefully. And even if not, just ask me very clearly. I can give whatever answer you're looking for. Whatever the confusion you're facing, your correct answer is C. Very next question, everybody. Then we have very next question, that the shortest wavelength in Lyman series of hydrogen is A, then longest in Paschen. I think similar questions have been done previously by me, and now we can assume this question as one of your homework. You can try this question by your own. It's a very simple question, exactly the similar question that we have done previously. So take one thing, try to find out the value of RH in terms of lambda, put in the another formula, and then you will get the correct answer. And D will be the correct answer. So wherever the different questions will come, I'll definitely give the answer. Like we have this question with us. We have energy of an electron is given by negative 2.178 into 10 to the power minus 18 joule z square by n square. And the wavelength of light required to excite an electron from n equals to 1 to 2 will be what? It's very easy question. We also know the value of delta E. Delta E is that wavelength is required, right? Wavelength. There could be two things which we can do. One thing could be just using the value. Let's C by lambda is equals to delta E is equals to 2.178 1 by n1 square minus 1 by n2 square. And we are talking about hydrogen, not a problem. This thing will become 3 by 4. Solve this thing. This is 2 into 10 to the power minus 25 by lambda. This is equals to 2.178. This will become lambda is equals to 2 into 10 to the power minus 25. 2.17 10 to the power minus 18 into 8 by 3. This is like coming 1 only. Just cut them out. 2.172, we'll remove it. This is coming like 8 by 3 into 10 to the power minus 7 meter. So what is 8 by 3? What is 8 by 3? I think 2.8. This is A is the correct answer in this way. I think A should be the correct answer. Is it? No, it's giving D. So somewhere we have committed a mistake. Maybe we have committed the mistake, or maybe the question has been given up incorrect. And wavelength of light required to excite electron from hydrogen atom level 1 to 2. But again, I think we are right. This is not correct. I think that we have done it correctly. Maybe this thing has an issue. I think A should be the correct answer. What should I say now? We try it with HC by lambda, and this is having 3 by 4. Okay, wait now. Why did I write 3 by 8 instead of 3 by 4. Can you tell me why did I write it 3 by 8 unnecessarily? This is 3 by 4. So that's a manual error, everybody, and I would like to suggest you people that always recheck your question once you do it. This is 3 by 4 actually. And using this information, the lambda must come up as 4 by 3 into 10 to the power minus 7, and then nearly it will become 1.3 into 10 to the power minus 7 angstrom. No, sorry, meter. This should be your correct answer. I think D is perfect. D is perfectly attempted. I think D has been correct. D is the correct answer. But again, this was some good question we had. This was some good question we had, and the question took us some enough time. The next question is, the ionization enthalpy of hydrogen atom is this much given over here. The energy required to excite from N1 to 2. I think this similar question we have done it earlier. And the ionization energy is equals to RH, or just simply do it. Okay, do it like this: RH into Z square and 1 by 1 square. So this value is exactly 1.312 into 10 to the power 6 joule mole inverse. So you can find out the same value for the energy required for exciting electron in atom from N equals to 1 to 2, and for the same, so energy delta E from N is equals to 1 to N is equals to 2 will be how much? This RH Z square 1 by N1 square minus 1 by N2 square. N1 is 1 square, N2 is 2 square. So this is your RH. How much is RH? How much is RH, by the way? How much is the value of RH here? We recently found out. Okay, this is 1.312. 10 to the power 6 multiplied by this value will come up as 3 by 4. 1 minus 1 by 4, 3 by 4. Solve it and you'll get your answer. So I don't need to just redo it, and I can see that this value will be higher than 1.312, and in fact it is even beyond 13. Huh? No, just a bit lesser than 13. Just a bit lesser than 13. I think D. What we should pick? D. Our only correct answer is D. And I guess you can try it by your own, but nearby 9.84, 10 to the power 5 joule per mole, you will be getting your answer. D is the perfect answer we got. But guys, we are right now going with very good speed, as I can see that from around over 40 questions have you solved, like more than 40 questions in just 1.5 hour. Excellent speed. Even in the terms of numericals, we are going. Great speed, everybody. Appreciable. Now we have the next question with us. We have the next question that the wavelength of the radiation emitted when a hydrogen atom falls from the infinity to stationary, what will it will be? RH is this. Another easy question, by the way. So N1 is equals to 1 and N2 is infinity from which it is falling. So now the formula is simple, that wavelength is being asked. 1 by lambda will be equals to, this is your RH 1.097, 10 to the power 7, and into Z square, Z is 1. 1 by N1 square minus 1 by N2 square, 1 minus 1 by infinity square, this amount is 0. Your answer will be lambda is equals to 1 upon 1.097 into 10 to the power minus 7 meter. You can also convert it into nanometer by simply doing two things. Make it 100 by 1.097 into 10 to the power minus 9 meter, which is exactly equals to, this value is somehow lesser than 100. So a little lesser than 100 will be how much? A little lesser than 100 Little lesser than 100 will be 91. 91 nanometer. Now let me see if we are right or not. Absolutely it's right, sir. Sanjay sir is solving the question, how come we receive incorrect values? It's always correct. C. And then we have the next moment from here, which is your Planck's quantum theory. But before starting your Planck's quantum theory, let us have a small break, everybody. We'll be having a small break here. So everybody please like the session, those who haven't liked. Hello. So hopefully we had some small and Hindi break. I ran, actually come back to join the lecture, and so guys, am I audible properly to every one of you? Let me just rejoin our session. Okay, don't go anywhere, everybody. Fine. Let me just start and quickly resume our lecture from there. So well, now continuing our lecture, we had Planck's quantum theory, and from here we are going to start it again. So guys, what is Planck quantum theory? Let me just take you to idea. Quantum theory and photoelectric effect both belong to the particle nature of electromagnetic radiations, a non-continuous or a quantized nature that actually helped Bohr to give his atomic theory and a quantized model. We will start it from the basic question. A hypothetical electromagnetic wave is given over here, and the frequency will be what? That has been asked. How can we find out? Okay, so just find out lambda first. So lambda is the length of one wave. So like a consecutive between two consecutive trough or crust, the different distance 1.5 picometer is exactly this 1/4. This is the this is your actually complete lambda. So if we compare these two, what we'll be getting, lambda is equals to 4 times of 1.5 picometer. That is exactly 6 picometer. So once you got the lambda, then now it is pretty easy to find out the frequency. The frequency will be what? C by lambda. How much is C? 3 into 10 to the power 8. How much is this? 6 into 10 to the power minus 12 meter. So the correct answer should be, and this is meter per second. So the correct answer should be hertz, 20 hertz, 3 by 6. So 5 to 10 to the power 19 hertz is the correct answer. I think 5 is the correct answer. And I guess 5 is only the given answer. 5 is correct. So that's how easy this question was. The most basic and most easy question we had. We'll now move forward to the next question that was asked in JEE in 2024. The question is pretty simple, everybody. Chahat Kumar, you have submitted the correct answer. Great. JEE in 2014, this question was asked. This question is based upon what is it, by the way? The same electromagnetic spectra. So candela is the luminous intensity and is given in the direction of the source that emits monochromatic frequency, a radiation of the frequency. The frequency is given to you A into 10 to the power 12 hertz, and that has a radiant intensity in direction of 1 by B. Watt per steradian. So what is the value of A and B that we have to find out? That is it. That's it. Aren't we given up with any other information? Are we given up with enough information or not? Let me check the question again. Are we given with enough information or not? This is what how much candela or what is the intensity? Nothing has been given to us. Okay, it's a typical seems a very typical theoretical question. So we'll keep this question in a side, everybody. Don't panic. We'll keep this question in a side. It's a typical theoretical question, completely based upon some concept. So let's say if the question repeats in future, we'll take this idea that the candela is the luminous intensity with a frequency of 540 hertz. And we also must remember that the radiant intensity will be 1 by 683. So this is somewhere the answer is given, but I'll come back to this topic later. I'll come back to this topic and we'll explain this part once more. So, okay, A and B were asked. So C should be the correct answer as of now. And as of now, keep this question in a side. We'll come back to it and we'll discuss these terms once more in later time. We'll come back to our ongoing topic, and the same thing is given here. The ionization energy of sodium in kilojoule if the electromagnetic spectrum radiation of the wavelength 242 is just sufficient to ionize the sodium atom is what? Very simple question. We already have been given up with the lambda. So lambda is given to you 242 into 10 to the power minus 9 meter, and what we have to find out is in nanometer is given. Calculate the ionization energy, and energy should be in kilojoule per mole. So there is one thing that we can do is simply find out the Hc by lambda, but that will be per atom. Do one thing, just try to find out the value of energy in electron volt first. So electron volt per atom, the energy will come up as 12400 or 1240 by 242 nanometer. So this is something which you are getting in electron volt. This is your energy. So energy in electron volt multiplied by 96 or like multiplied by 95.8 will roughly lead you to the value in energy in kilojoule per mole. So that's what we have to solve. You have this equation with you. This will be roughly coming up like let's say 5 and 5 to 98.5. So somewhere nearby 400 something can be your answer. 494 is the answer. But I would like to suggest you that randomly, let's not go here randomly and try to solve this equation or this expression one by one, because this may lead you to some incorrect answer also. If let's say this is a nearest integer type of question or a subjective question, that we must follow everything, and otherwise what will be happening? We might be getting our answer, but like 492 or 490 or like 500 it may go, but that can be an incorrect answer. That was some question, by the way. A question asked in JEE 2023. The question says that the number of incorrect statement about the black body given over here, it emits or absorbs the energy in the form of electromagnetic radiation. That is true. So the frequency distribution of emitted radiation depends upon the temperature. Does it? Yes, it does. True. Then at a given temperature, intensity versus frequency passes through a maximum value at a given temperature, intensity versus frequency. Now intensity and frequency are not related as I see. The maximum value, the maximum of the intensity the maximum of the intensity versus frequency curve is at higher frequency at higher temperature compared to that at the lower temperature. Let me rethink of it. The maximum of the intensity versus frequency curve. From where have we started these again, man? Got it. So at higher temperature, it reaches to the higher peak. It's right. So we have this intensity versus frequency graph here, everybody. And intensity is expressed in terms of watt per meter square per hertz. And this is your frequency and this is your intensity. The graph somehow comes like this and like this. This is somewhere we are going at the higher temperature. So let's say temperature be here 5 Kelvin. Let's say temperature here be 2 Kelvin. Okay, now take the idea. A given temperature, intensity versus frequency passes through a maximum value. Of course, this is again true. And the maximum of the intensity versus this curve, maxima, is at higher frequency, at higher temperature, correct, compared to that of the lower temperature. The maximum will be higher for the higher temperature, I can see. So I think this is also true. Talking about this curve. What is the correct answer? 0. 0 is correct. 0 is the correct answer, everybody. All of these given points are absolutely true about frequency and intensity of the light. 0 number of options are incorrect here. The number of incorrect options have been asked. Now coming to the next question, we have assertion reason question is here. Assertion says that in the photoelectric effect, the electrons are ejected from the metal surface as soon as the beam of light of frequency or greater than threshold frequency strike. This is true. Absolutely true. Reason is when a photon of energy strikes to an electron, transfer the energy from the photon to the electron takes place. Energy, any energy is incorrect. It should be more than the threshold frequency and threshold energy, or we can say it should be even more than the work function. Then only it can eject out the electron, and then only it can transfer energy to the electron. Otherwise, it will not work. Correct answer should be true and false. A is true, B is false. Correct. Finally, some good question came, which we have attempted it correctly. Next is the values of the work function W0 for a few metals have been given over here. The number of metal which will show you photoelectric effect where 400 nanometer falls on it. So first of all, you do one thing, try to find out the value of phi, which is your work function. So once phi is calculated, then we can apply these all values and can find out the required thing. Initially, we'll find out phi. How? Phi is, it's an electron volt, thankfully. It will be 12400 and 1240 divided by simply 400. So this will be in electron volt per atom. How much is it, by the way? It's 3.1 electron volt. So whoever is having lesser value of their work function than this amount of energy, okay, no, this will simply say that this is your lambda. Oh no, lambda is 400, then this is the energy of photon, by the way. The energy of photon is 3.4 electron volt. If energy of photon is 3.4, so whoever is possessing lesser than that will be ejected out. Check it out, 2 and 3, nothing else. Can we see the answer? Can we check the answer? Is it 3? Absolutely, it is 3. Coming to the very next question from here. If the wavelength of an electron emitted from hydrogen atom, the wavelength of an electron emitted from hydrogen atom is this, then the energy absorbed by the electron at its ground state compared to the minimum energy required to escape the electron will be what? And what we call it is as the phi. So we already are having We already have the wavelength of an electron emitted from hydrogen atom is this much. Lambda is given to us. Then the energy absorbed by the electron in its ground state comparing to the minimum energy required to escape from the atom will be what? Now, this seems some good question, by the way. Wavelength is given to us. So what we can find out is the value of energy here. So this is energy in electron volt, and this is the amount of energy of a photon which is actually leaving us. So it will be 12400, a shortcut, a formula I told you once. I was teaching you this theory related to this concept that energy of a photon will be 12400 by lambda in angstrom. So angstrom, it will be 3.3 angstrom. And now it will become what? On solving, it gives you a value of around, I guess, around 3. So like and we have to find out the, so this is like 33, 3.3, 33, 12400. I can write it like 1240 into 100 by 33. This value is 3. So it will be giving you 3720 electron volt. This is the amount of energy which is releasing when electron falls from the if the wavelength of an electron emitted from hydrogen is this, then energy absorbed by the electron in its ground state comparing to its minimum energy which is required to escape the electron from the atom is what? So minimum energy to require the escaping will be, oh no, what is it here? 2. Not getting the exact concept here. Let me check the solution first, if it is with me. What we are right now giving is value of K. Wavelength for an electron emitted from hydrogen atom is this. So this is some energy which has been eliminated. Okay. Now then the energy absorbed. So this is let's say energy absorbed must be equals to energy which is minimum required plus energy of the photon emitted out. This is the amount of energy. The energy absorbed by the electron in its ground state comparing to the minimum energy is required. So let me just divide it by, we have to required energy absorbed upon energy required will be equals to 1 plus energy of photon divided by energy of required. If the data is correct or not, yeah. So energy of photon upon energy required. So we have to find out the minimum energy required and then we can get the final answer. Why is it coming minus 10 only or something? Is coming, no? Let me check the data. 10 to the power minus 10 is given only. So anyways, we must find out energy which is required, and energy required will be how much in terms of electron volt? That is 13.6 Z square by N square. That is the ionization energy, by the way. This much amount of energy is first of all required to eject it out. That is 13.6 Z square. And this is equals to ionization energy or phi 13.6 Z square. 1 square electron volt. So 13.6 electron volt only. Oh, this is confusing me actually. So anyways, we'll come back to it. We cannot waste our time, everybody. I can do one more thing from here. So what is actually energy absorbed upon energy required will be equals to 1 plus how much was the energy? It was given up as 3720 divided by, the answer is 2 here, no, which is not ours, and this will be like 13.6 electron volt. No idea how is it coming to. Anyways, it maybe we are missing something as a concept. We can come back. We have 2 questions in our mind that we can come at the end, and let's not waste our time. We have plenty of questions for the day, so we'll move forward as of now, but we'll come back to these questions and we'll retry these questions. Okay, don't worry, guys, I have these questions in my mind. 2 questions are there. One is this, the another one was the that luminous intensity and all that we'll explain. Now the next question we have is also from JEE in 2022. Even the previous one was JEE in 2022, and it's a good question, by the way, we got. The question says that the minimum energy that must be possessed by photons in order to produce the photoelectric effect with platinum metal is what? And the threshold frequency is given. So anyways, this is not a great question comparing to the previous one. It's an easy question relatively. So what we are going to do is, minimum energy that will be possessed by photons in order to produce the photoelectric effect. Threshold frequency is given to you and minimum energy is needed. So simply do H into nu, that is phi. So this is the minimum energy we need. H is 6.63, 10 to the power minus 34 multiplied by 1.3 into 10 to the power 15. The correct answer should be 13. 6 is what? So this is 6.63 into 10 to 1.3. Somewhere 8 or 9 we can get, and then 10 to the power, how much are we are getting? Minus 19 joule is the correct answer. I guess 19. C is the correct answer. So using the rough calculations, we can also find out the correct answer. Not a big deal. Coming to the next question, we have the work function of a metal is 6.63 10 to the power minus 19 joule. The maximum wavelength of a photon that can be required. So maximum means it is asking us for the lambda naught, and how come lambda naught is connected with this amount of energy is written down as in nanometer. We have to give the answer. So what I'll do, and I have plenty of processes to do this question, but I'll use the most easier one. Or we can see simply we can write hc by lambda. So guys, hc by lambda is equals to 6.63 into 10 to the power minus 19, and which is exactly equals to the phi. So we are supposed to find out the phi lambda. So lambda will come up as h. How much is that? 6.63 10 to the power minus 34. C is 3 into 10 to the power 8 divided by 6.63 into 10 to the power minus 19. So this will be eliminated out. Minus 19 plus 8 is how much, by the way? 19 plus 8 is 27. On 27 it will become 3 into 10 to the power minus 7 meter. Or we can simply say 300 into 10 to the power minus 9 meter, or 300 nanometer. Is 300 nanometer correct answer? 300 is correct. Hopefully some correct answers. Next is JEE in 2021. We have a question that came in JEE in 2021 in the 1st September. Okay. 50 watt bulb emits out a monochromatic red light of wavelength 795 nanometer, and the number of photons that were emitted per second by the bulb is this. Then what is the value of X? I guess it's an easy question, because we right now are having 50 watt bulb with us. Are we given with the time? Okay, per second it is saying. So guys, time is 1 second. So energy will be what? Power multiplied by time. So power is 50 into 1, that is equals to 50 joule. Now energy has been given us. So energy is equals to n times of EP, where n represents the number of photons. You remember this formula? How much is the energy we have? 50 joule. Must be equated with the number of photons multiplied. What is the energy of 1? That we got to find out. 795 nanometer. There are plenty of things, but we can use this hc by lambda. 3 into 10 to the power 8 h into c. So h is 6.63 10 to the power minus 34 hc by lambda. How much is the lambda? 760 not 60 95 into 10 to the power minus 9 meter. I think this is how we can find out the value. N will be 3 into 50 into 795 into 10 to the power minus 9 upon 3 into 10 to the power 8 into 6.63 into 10 to the power minus 34. Just solve this and you will be getting your answer. Correct? In terms of 10 to the power 20. The answer is 2. Good. Chahat Kumar, very good. Keep it up. We have a question in 2021. This question was asked: the number of photons emitted by a monochromatic source infrared range finder of power 1 what is it, milliwatt, and wavelength of this one, and time is also given in this. Exactly the same question. The energy and the total energy is equals to how much? 1 milliwatt multiplied by time. How much is the time? 0.1 second. 10 to the power minus 4 joules. This total energy is equals to n times of energy of the photon. And energy of photon can be find out using number of photons. 1000 nanometer. Hc by lambda, and we'll use lambda as 1000 nanometer, and that's how you can find out the value. So do you want me to solve this question, or you can do it by your own? As I can see, it can be easily done by your end also. So you will be get n as 50. Coming to the next question. When a light of wavelength 248 falls on the metal surface of threshold frequency 3 electron volt, the de Broglie wavelength emitted an electron is what? So we have to find out the lambda, de Broglie wavelength. Light of wavelength 248. Okay, first you find out the kinetic energy. Probably from there we can find out the remaining part. So first we will do what? Well, first of all, we will try to find out the value of kinetic energy. Kinetic energy maximum will be equals to energy in a photon minus work function. How much is the energy of photon here? 248. So 12400 divided by 248. Nanometer, just remove 1 0. This is electron volt minus 3 electron volt. This is, I guess, how much is it? It's 2, 5. So this will be giving 2 electron volt. If you know the value of kinetic energy here in electron volt, you can convert it to energy in joule, and then you can find out the value of lambda de Broglie wavelength is lambda is equals to h upon root 2m kinetic energy. So h is how much? 6.63, 10 to the power minus 34 divided by under root of 2 into mass is 9.1 into 10 to the power minus 31. Kinetic energy is how much? 3 into 2 into 10 to the power 2 electron volt. So 1.6 into 10 to the power minus 19. So everybody, so guys, that's what we have with us. Just try to solve this equation and you will get the value of lambda. Can we see what will be the value of lambda here? We have plenty of varieties of the question here. Although the same formula has been used here, but can you see we have a lot of like the similar kind of questions here. So I guess you can solve it and answer will be nearly 9. Okay, means you will be getting this whole value as somewhere. So whatsoever, man. 9 in the terms of 10 to the power minus 10 correct answer will be there. One more subjective and very easy question. A theoretical question, everybody. JEE Main 2021, this question was asked. The question is very easy, that among the following the number of metal that can be used, and I guess only cesium can be used. I have no clue whether A1 is the correct answer. Correct. The only metal is cesium, not lithium, rubidium, sodium. And we cannot use, like there are plenty of reasons behind that. Lithium has a higher value of ionization potential, cannot be used. Sodium, potassiums are quickly reactive and can't be left. And also they have relatively lesser value, a higher value of ionization potential than cesium. 1 is the correct answer. So that was the most easy question till now we had. Then comes the work function of sodium metal is 4.41 into 10 to the power minus 19 joule. If the photons of a wavelength 300 nanometer are incident on the metal, then the kinetic energy of the ejected electron will be what? So try this question, everybody, please try. The work function of sodium metal is this much. What I'll do, if the photons of wavelength of this, same questions are asking, man, the kinetic energy we have to find out maximum will be equals to simply apply hc by lambda minus phi, hc by lambda 2 into 10 to the power 25 negative divided by lambda is 300 10 to the power 9 minus phi is 4.41 10 to the power minus 19, and if it is asked in nearest integer, so somewhere around, let me check. This is the only thing that we have to find out, everybody. Solve it and you will get a value of 222, but do it carefully. It will not be giving you the correct value if you use any shortcut here. There is another question. There is another question we have. Very next question. So the figure that is not direct manifestation of a quantum nature of an atom. Which of them is not representing the quantum nature? So quantum nature is a particle nature actually. Quantum nature is what? Particle nature. Internal energy versus temperature. Internal energy. What is it? Internal energy keeps on increasing. Discrete lines. Particle nature. Particle nature. I think A is the correct answer. What do you think? A is the correct answer. Because internal energy of a gas argon we are using right now over here, and with temperature it is keep on increasing. It's a function of, what is it a function of? Well, internal energy is keep on increasing with increasing temperature, 3/2 kT. But again, the thing is it's not representing discrete things. It's not representing. It's whatever it is representing is a continuous nature. So it's not a quantum nature. It's more or less wave nature. We can say continuous nature. Next, in 2019, this question was asked that if P is the momentum, P is the momentum of fastest electron ejected from a metal. Fastest electron. The irradiations of light having wavelength lambda, and then for 1.5 p momentum of the photoelectron, then the wavelength of the light should be what? Another easy question here. Electron ejected. The wavelength of the light should be what? Wavelength lambda. Assume that the kinetic energy of the ejected photoelectron will be very high comparison to the work function. This seems some good question, by the way. And we got 2 or 3 answers. Chahat and Agrim are saying D, but let's check out. So if P is the momentum of the fastest electron ejected, or what should be the fastest electron ejected, by the way? So we can just simply write down the equation and then we can relate. What do you think? Shouldn't we just write down the equation, then we can relate? So this is like energy of incident photon is equals to kinetic energy maximum plus work function. Okay, and the fastest electron means, so it's also saying that kinetic energy is very huge, so this equation can also be written down as kinetic energy maximum, and this is incident photon, by the way. Somebody is submitted C as the answer, but I would like to check it first of all. Chahat has submitted C. Now P is the moment of the fastest electron ejected from metal surface after the radiation of light having wavelength of lambda. And then for 1.5 p momentum of the photoelectron, the wavelength of the light should be. So how can I find out the value of Ke? So there we can have this in the terms of momentum. So kinetic energy maximum is equals to 2 root 2m momentum is equals to root 2m kinetic energy. So energy P is equals to under root of 2m kinetic energy. Okay, so kinetic energy will be how much? Will be P square by 2m. So if we have 1.5 p momentum of photoelectron, the wavelength should be what? Kinetic energy is this. Okay, 1 by root 2m Ke. So isn't it half then simply? So guys, let me give you the easiest way to calculate out this value. Let me put you the easiest method over here from here. So this is how we got EP equals to kinetic energy. And we also know that energy of photon and kinetic energy maximum, how come these two are related? That lambda is equals to h by p and can also be h by under root of 2m kinetic energy, isn't it? Under root of 2m kinetic energy. So this one is your lambda, only simple lambda. And we all know that kinetic energy no idea. Okay. Do it in this way. Do it in this way that since momentum is equals to root of 2m kinetic energy, so kinetic energy will become what? P square by 2m. P square by 2m. So using this value, what we can see that energy of photon is equals to hc by lambda is equals to, in initial case, it is like P square by 2m, equation 1, and then energy of photon dash in the next case it is lambda dash that we have to find out. will be equals to P is 1.5 P. 1.5 P square upon 2m. But this is equation 2. So we can simply find that EP dash by EP, or like if we divide these two parts, then we can get what? That lambda dash 1 by 2. Equation 1 by 2 we are doing equation 1 by equation 2, and we can simply get the value. We will get the value 1 by 2 as lambda dash is equals to lambda dash by lambda is equals to 1 upon 1.5 whole square. This is your 1.5 is what? 3 by 2. So basically this is like 4 by 9 lambda. This is the correct answer. I think this is how you have approached. It was a good question, but it took us like some time. Somebody is also asking like when am I going to take the plus lecture? Sir, plus वाली classes कब resume होंगी? Very soon guys. आप कौन से उसमें हो? ड्रॉपर 11th 12th क्या? Next question is, the upper stratosphere consisting of ozone layer protects us from the sun's radiation that falls on wavelength of what? What does it come with? Ultraviolet region. Ultraviolet region is having higher energy than visible, and visible lies somewhere around what? Like 400 to 700 kind of 750. So it should be lesser than that. 400 say lesser than 400 could be, I think, A. A is correct. Okay, it was a simple guess based question. So if you have this information of electromagnetic spectrum, you can solve this question easily. We have very next question then. This is directly proportional to symbol. The de Broglie wavelength lambda associated with a photo electron varies with the frequency nu of the incident radiation. So basically how we can do is, we can find out the value of kinetic energy first. Kinetic energy maximum will be equals to nu, h nu minus h nu naught. So it's simply h into nu minus nu naught. This is a constant. We also know that in terms of kinetic energy, the de Broglie wavelength lambda, de Broglie wavelength can also be written down as 1 h by under root of 2m kinetic energy. And kinetic energy is what? H into nu minus nu naught. So isn't it like lambda dBW is directly proportional to nu minus nu naught raised to power half of minus. So like 1 upon. So D is the correct answer. It's a simple question, by the way. D is the correct answer. Okay. एडवांस के क्वेश्चन भी कराएंगे, क्यों नहीं कराएंगे? विल कम अप विद दैट सीरीज ऑल्सो. अभी तो हम लोग ऑन द प्रैक्टिस नोट मेंस के 2002 से 2025 कवर करेंगे. Anyways, now we have the next question with us, everybody. Try solving this question with me. The question has appeared in JEE 2018 on 15th of the April morning shift. Question is pretty simple. Says that the ejection of photoelectron from metal in photoelectric experiment can be stopped by applying a 0.5 voltage. So the work function of metal should be what? So what you are getting, by the way, you have three things here. One thing is kinetic energy maximum, which is exactly equals to the energy of incident photon minus phi. Something related to phi has been given to us, which is 0.5 volt. No. Work function has to be asked. So work function is asked. Phi will be equals to kinetic energy maximum minus EP. Yeah, sorry. EP minus kinetic energy maximum. How much is EP, by the way? Incident is 250. So I'll put it 12400 or 1240. In case of nanometer, we'll just put it 250 minus kinetic energy maximum is how much? 0.5. So E into V naught. Getting me? Or you can just simply put 0.5 volt. It is like multiplied by E, electron volt, it will become energy in terms of electron volt. So we have got this equation. Phi should be what? This is 250. Like it's 1000 by 4. No, 4. So just try to solve it like this. Make it 1000 by 250 into 1.240. This will give us 4. The correct answer should be, I don't know, but by the way, 4 times of this 1.25 into 4 is how much? Somewhere 5 minus 0.5. 4.5 electron volt. B. Then next question is came in AIEEE 2011. I hope now some lesser questions are left because the similar concept is repeated now. Gas absorbs a photon of 355 and emits out 2 wavelengths. One of them is this, then another one is it. I will write down this expression for you. You will solve it by your own. That energy of photon is equals to gas absorbs a photon and gives 2 wavelengths. So this will be like E1 plus E2. In terms of lambda, we can write it 1 by 355 is equals to 1 upon 680 upon 1 upon watt. So you need to find out this value. And I guess this will be loud. Let me guess. Some double of this. Around. Okay, thank you, by the way. Many of you are like praising me for my consistent support and consistent efforts what I'm continuously bringing here. So thank you guys. Thank you for your appreciations, and that's what works for a teacher. So every time student keep on appreciating teachers and teachers get motivated. So thank you for that. And yeah, don't forget to like the session. So those whoever are enjoying my session, do like the session on priority. Now we have the next topic of the day, everybody. Right from the previous one, we had like we have finished 2 major topics till now. No, in fact 3. Let me just remind. Bohr's theory has been completed, hydrogen emission spectra. Then later on we came to the particle nature of EMW, electromagnetic radiations. That was kinetic theory, photoelectric effect and Planck's quantum theory. Now something is here with de Broglie hypothesis. De Broglie's hypothesis, some of the questions we already have solved, some of them will right now apply here. And believe me, this is another very easy concept. The frequency of de Broglie wavelength, de Broglie electron in Bohr's orbit of hydrogen atom is this. What? Frequency of de Broglie. So frequency if we have to consider just de Broglie, just first of all find out the energy first. So this energy E1 is equals to 2.18 into 10 to the power minus 18 joule, which is equals to the kinetic energy. Kinetic energy for n is equals to 1. So kinetic energy is known, then what you can find out is lambda, not lambda. It's asking for the frequency of de Broglie, right? Frequency for the de Broglie, it is asking me. Frequency of de Broglie. We already have kinetic energy. We can find out lambda, but velocity is already known to us, right? Using this part we can find out the velocity. (658). So isn't it like simply going for h nu? So you can get the value of nu here. Like both of the things can be done. So let's see one more time. I must try this question. Ten to the power 13 we have to give the answer up to 34 minus 18, 16. This is 21.8 upon 6.63 into 10 to the power 15 hertz. Not 15, just 658 is the correct answer. Frequency of de Broglie wave in Bohr's first orbit of hydrogen atom is something hertz. So frequency, how did we find out the frequency? Yeah? We know the value of kinetic energy. We can find out lambda from there, and then not by HM, by NV. Let me just check. Chetan says 661. Again, some nearby. Got it. So guys, we are now with kinetic energy, which is also equals to h nu. So we also know that lambda is equals to h by mv into v. So let's say if I am multiplying this whole equation by like dividing it by velocity, so it will give me like velocity into this thing can be written down into lambda can be written down as velocity by frequency is equals to h by mv. So there we get the value of nu as, sorry, this is simply nu, frequency as cross multiplication mv square by h, and we already know the mv square value here. So this is like half of this value we know, double of it will be 4.36 into 10 to the power minus 18 divided by h, 6.63 into 10 to the power minus 34. Now please solve this value and get your answer. It will be roughly coming as 658. That's how you will be getting the complete answer, 658. Yes, Chetan, you are right. 2 से मल्टीप्लाई कीजिए, you're right यार. I got it a bit lately, but anyhow we got it. Next is another question, came in just JEE Main 2024 only. The de Broglie wavelength of electron in 4th Bohr orbit is what? In terms of pi into a naught, and a naught is Bohr radius. Bohr radius, you all know what is Bohr radius. So this is your n is equals to 1 for hydrogen. So n is equals to 1 for hydrogen. So de Broglie length for 4th Bohr orbit will be what? So mvr बराबर n lambda. Fourth Bohr orbit you have to find out. Let me just take a refreshing start from here. So mass, velocity, r, n lambda, we know this equation, and radius we can also find out as a naught into n square by z, n square by z. Z is the same only. So this r4 will be becoming what? 16 a naught. So lambda will be equals to what? So 4 into lambda is equals to m into v into r is what? 16 a naught. So man, I'm tired now. We did this question exactly a second back only, yaar. Like an half an hour back, we did this question. The de Broglie wavelength of an electron in 4th Bohr orbit will be what in terms of this? So do one thing, guys. What MB are, yaar? Are we mad or what? This is 2 pi r. 2 pi r is equals to this. Do one thing. Just simply apply mvr is equals to nh upon 2 pi. First do it, and then this will be 2 pi into r will become what? nh upon mv, or 2 pi r upon n will be your h upon mv, and h upon mv is what? Lambda dBW. So, and r is what? R is equals to 0.5 a naught into n square. So r for n is equals to 4 will become what? A naught into 16, 4 square. Just put this value there. So lambda de Broglie wavelength will be equals to 2 pi r by n. And this is 2 into pi into 16 a naught upon 4. Now solve it. I guess it is 8 pi a naught. So that's how we get it. 8 should be the correct answer. 8 is correct. Then one more question came in 2016. A stream of an electron from heated filament was passed between two charged plates capped at a potential difference V where E and M the charges. This is their most easy questions of the day I have found. So guys, you know what? Since lambda is equals to h by mv, so h upon lambda will be equals to what? Cross multiply mv. So we know what is mv. Do you know what is mv? Momentum, which is equals to what? Root of 2mke. And kinetic energy could be what? E into v. 2mev root 2mev. C is the correct answer. That's great. That's good. C is the correct answer, everybody. C is the correct answer. Very good. So we have plenty of students now joined me and just greeting me. Thank you. Now I'll take you to the next question. By the way, this question has appeared in AIEEE 2010, and in an offline exam, the question says that the energy required to break 1 mole of chlorine is 242. Longest wavelength of the light capable of breaking this bond is what? You know what is the meaning of longest? Like right enough to break down this bond. And if you are increasing the wavelength, then the energy will become lesser and it will not be able to break the chlorine-chlorine bond. So it's just like this. It's a chlorine bond attached here, chlorine bond. You required a photon. This is a photon. This energy of photon is actually hc by lambda, and we got to find out the lambda for this. So just simply apply this formula. There are like plenty of things that you can do, but I have the shortcut over here. If you want to apply with me, just 242 kilojoule per mole is equals to energy in electron volt multiplied by 96.5. That time I used something else or what? The same thing only. Probably the same. Anyways, we can find out. Energy in electron, it was 12400 divided by energy in, okay, in nanometer, this is 1240 by lambda in nanometer. Multiplied by 96.5, and now you find out the value of lambda from here. Everything is given to you. It will be more or less like 1240 into 96.5 divided by 242. Now check it out, everybody. What value are we getting from here? What value are we getting from here? Oh, this is something 5, I guess. So let's say this is something nearby to 5, and 5 multiplied by 100, 500. And a bit lesser than that we'll be getting. I think D could be the correct answer. It is what I think so. So D is absolutely correct. Even I guessed it. And that's what I want everybody of you. Just guess it and get the answer. We have another question. AIEEE 2009. This question was asked in an offline exam. Calculate the wavelength in nanometer associated with the proton moving with this. I'm not gonna to solve this question literally. It's one of the most easy question. We can do it by our own using this formula. You simply put the lambda, which is your de Broglie wavelength associated with the proton, will be h upon m into v. You know the mass of proton, which is 1 AMU, which you can put 1.66. 1.67 10 to the power minus 27 kg. 1 AMU. Velocity has been given to you 10 to the power 3 meter per second. And then h is 6.63 10 to the power minus 34. Just solve it and you'll get your value. How much is it, by the way? A is the correct answer. A de Broglie wavelength of tennis ball moving with its mass is 60 gram, moving with a velocity of 10 meter per second. I don't know why should I calculate this value. It's the most easy question. Lambda will be equals to h by ph upon mv. You already know h, 6.63 10 to the power minus 34 divided by mass is 60 gram into 10 to the power minus 3. We have to take the mass in kgs. Then in velocity you put 10 meter per second. And now something that we don't need to do is basic calculation, and we'll be getting our answer, that is D. Finally, Not finally, we have plenty of other topics as well, or probably we can have another short break from here. Not from here, we'll solve this topic as more, and then we'll plan a break, and then right after this break we'll be having some more concepts left with us, that is wave mechanical model, and then quantum numbers and electronic configurations. 3 topics are left for which we'll solve some more problems, and then we'll wind up the session. So the question is pretty simple, that Heisenberg's uncertainty principle, HUP, the very simplest formula that will be used everywhere is delta x into delta v is greater than or equals to h upon 4 pi m. It's that simple. Sorry. There we go. The question asked in JEE Main 2024, a very easy question. The based upon Heisenberg's uncertainty principle, the velocity of an electron is found within an atomic nuclei of diameter this is this. It's very simple, as I told you. Just take delta x into delta v greater than or equals to h upon 4 pi m. Value of delta x can be known. How? It's like the electron within an atomic nucleus of this. Try to put over here 10 to the power minus 15 meter only into uncertainty in velocity will be what? That has to find out. H upon 4 pi m. So h upon 2 pi we know. We calculated a bit. 3.14 into 6.63 10 to the power minus 34 divided by 4 into 3.14 into 9.1 into 10 to the power minus 31. Now solve this value and just calculate out the value of delta V. That is how I can help you with now, as of now. 58, are you getting 58 as a final value? Sure, exactly 58. Might be. Next is another similar question. The minimum uncertainty of speed of an electron in one-dimensional region of length 2a naught, where a naught is this. So guys, how easy this question could be. So the same thing which is been asked here, delta V, that should be greater than equals to h upon 4 pi m into delta x. Just everything is given, just put that value and you'll be getting your answer. Homework. Probably you will be stuck at one point, that is the exact calculation, but exactly this is what we want. This is what we want student to learn, that you have to apply your own knowledge of your calculations, because if I solve it over here, because something is there that I'm not using any shortcuts right now, because it's an integer based question. If I use any kind of shortcut or rough calculation, my answer may go beyond or far from the required one. So don't use any shortcuts in such a way. Everything is another similar one. Speed is given and its uncertainty is this, so delta V will become what? Speed multiplied by its uncertainty, which is 0.02 divided by 100. Then delta X has to be calculated out, I guess so. So delta X is actually required to find out, which is x into 10 to the power minus 9 meter. And simple formula will be delta V into delta X is greater than or equals to h upon 4 pi m. In an atom, moving with the speed of this, accuracy is this, it's the same question. So same question is here. I'll give you as a homework. Try it by your own. Uncertainty position is this. Moving with this, accurate up to this will be same question. Moving forward. Uncertainty position for a particle of mass this in space is this. What is uncertainty position? No need to do. Then in case of isolate, okay, which we have, what we have skipped now, okay, there we have. And So guys, I'm feeling a bit hungry, and I think it is the time that we all should have something to eat, and then we'll resume and continue. Okay, I'll give a break from here. So now that's what I call some healthy break. Hopefully you all are aligned here. So guys, those who took the break, come back, everybody. We have just a final session, the final part of this chapter belonging to the modern and the wave mechanical model is left here. So everybody please come and join back. Let's start. We have the last and final part, that is wave mechanical model. So in case of isolated species, probably that. Look at this question. In the case of isoelectronic species, the size of fluoride, neon, sodium is affected by, what do you think? Nuclear charge? None of the factors, because their size is the same. That is incorrect. Electron-electron interaction between orbital, because number of electrons are the same. Principal quantum number is also, I guess, the same in all of them. That also represents exactly the electrons. And I think nuclear charge is something which is Z effective, with Z minus number of electrons. Z effective, something that matters. A is the correct answer. We are right now working on wave mechanical model, the most new model, and let's see if we have this question with us. The question says that psi 2s, that means it's a wave function, some mathematical function. The wave function is given for an electron in belonging to 2s electron. Let me just rewrite this equation. It is given us as like psi for a 2s electron is given as 1 upon 2 under root 2 pi into 1 by a naught raised to the power half multiplied by 2 minus r by a naught into e to the power minus r by 2 a naught. Okay, this question came in 2023. Now it's asking us that if r is the radial node, at radial node, what will be the value of r naught in terms of a naught? So guys, at the rate r goes to r naught, psi square becomes equals to 0. So sum of the part of this equation will become 0, and that part will be 2 minus r by a naught will be equals to 0, and that's why r naught, what we were trying to find out, will become 2 times of a naught. Like one of the most easy question, just a simple application is being used. R naught is 2, A naught is the correct answer. Hopefully everybody is getting me what I'm trying to explain. C is the correct answer. Very next is, the question came in JEE Main 2022. Question is pretty simple, says that the energy of 1 mole of photons of the, I don't know, randomly questions are coming. 1 mole of photon will be having how much energy, and this is in kilojoule per mole we have to find out. The simplest formula says that energy, first find out in electron volt multiplied by 96.5 is equals to your energy in kilojoule per mole. That's the simplest formula derived in the previous class of its theory. Now the same chapter with theory, electron volt energy can be written down as 12400. Another shortcut, upon 300. If it is in nanometer, it take 1240. If it is in angstrom, it take 12400. 96.5. The energy somehow will be coming up as, this is nearly 4, I guess so. 410. So 410 into 96 will be like around 400. So 399, I guess. What do you think? 399 is correct answer. Moving to the next question, we have a question came in JEE Main 2022. Which of the most correct probability density curve 2s orbital? So previously when I was teaching this topic to all of you, I taught you some of the ways to find out how can we derive this part. Hopefully you all remember it. A 2s orbital has one radial node. 1s to 2s, the middle part is empty, vacant. It must touch this x-axis at once. Where can you find it is touching at once? Psi square can never be negative. This is incorrect. It's touching at once. This is the correct option. Absolutely. Next, a question from JEE 2021. The photos of radial distribution function for various orbitals of hydrogen against r radius is given here. So radial density is 4 pi r square. Its radial probability is given as 4 pi r square psi square into dr. And what we have to find is for okay, it's not mentioned for which we are finding. Okay, for hydrogen atom, I guess, no? Hydrogen atom has just 1s, 1 electron. So the only electron is present in first shell, and there will be no radial node as such. So graph should start from the 0, should come down like this. And let me check. I don't know when what's given here. So maybe it's a general graph which has been asked to us. I didn't get what it is trying to ask me. The photos of radial distribution for various orbital of hydrogen atom against r is given below. For which orbital they are asking for? Let me check this question if I'm getting it correctly. Sorry, my bad. This question is actually hidden. This question is given here. So just try to go, and it is asking for 3s orbital. For 3s orbital it is being asked. So simply for 3s orbital we will be having 2 radial nodes. So this is one first, the second, this is like 2 radial nodes are there, and that gives us the clarity. This should be the correct graph, D. So we cannot mention anything until or unless we are known about the orbital which we are talking about. For a 3s, there are like 2 radial nodes from 1s to 2s, 2s to 3s. Next question. The correct statement about the probability density except at infinite distance of the nucleus is, it can be 0 for 1s orbital. No. 1s orbital has 0 nodes. No nodes. Oh, this is incorrect. It can be 0 for 3p orbital. Probability can be 0 for 3p orbital, yes. And can never be 0, no. From 1s to 2s, we have 1 radial node. It can never be negative. Probability cannot be negative. I think B is the correct answer. Perfect. Next. Next question says that, JEE 2019, this question says that the electron is more likely to be found at where? Guys, wherever you find the psi having the maximum value, there you will be having psi square as maximum, which is actually the probability density. To find electron. Getting me? The correct answer should be there, here, and here. A and C. Where can you find A and C? A and C, B. Option number B is perfect. We have another question that the graph between psi square and r is shown and represents which orbital. So since we are getting here 1 radial node, where can you find 1 radial node, everybody? 3s. Radial nodes are 2. 1 to 2, 2 to 3. Radial node for 2p is 0 because p subshell starts from second orbit. Radial node is equals to 1. radial nodes are 0, our correct answer should be B, because we are required one radial node. Then orbitals and quantum numbers, the another topic from this chapter, and now we are right now reaching towards the end of this chapter with quantum numbers and orbitals, and then last topic will be your electronic configuration. There we have it. A question asked in JEE in 2024. Question is pretty simple, saying that in an atom, total number of electrons having quantum number n is equals to 4, m equals to this, and this zup. First of all, we have to identify for n is equals to 4, total electrons, 2n square rule, that is 32 electrons. Then next, out of this 32, if like say m is 1, so like this could be 4s, 4d, 4f, no yaar, 4s, 4p, 4d, 4f. Getting me? Like L is equals to what? 0, 1, 2 and 3. So this is how it can look like. Okay. So out of which we have to take m just equals to 1. So only one orbital will be taken, one orbital will be taken, one orbital will be taken, and one orbital will be taken. And spin also should be negative half. So this 1, 2, 3 and 4. I guess 4 should be the correct answer. What do you think? 4 is the correct answer or not? 6 is the correct answer, then we are wrong, yaar. What's wrong with everyone over here, yaar? Number is, okay, 0 to n minus 1. So 0, 1, 2, 3. Orbital ml is equals to 1. So this 1, okay, bad. If ml, magnitude of m is 1, then this could be plus minus 1. My bad, actually. If ml is equals to 1, then ml could be plus 1 or minus 1. So for 4s we have nothing. 4p we have 2 orbitals as such, 1 with a plus 1 name, 1 with a minus 1, and out of which only 2 anti-clockwise spin we are picking. The same over here, plus 1, minus 1. Plus 1, minus 1. So what do you see? What do you see? Six orbitals are now the perfect answer. 6 is the correct answer. But that was a tricky question, by the way. If some question can trick your teacher, why can't you? So just be prepared. Look at the question twice. If you are in a bit of hesitation that maybe we are wrong, just look at the question twice. Let's come back to the next question we have. A question that was asked in April evening shift in JEE 24, the very last year. The maximum number of orbitals which can be identified with n equals to 4, m equals to 0. Now I can rely on this part. So if n is equals to 4, then L could be 0, 1, 2 and 3. And then if you want to have m, L is equals to 0, 0, 0, 0, only one atomic orbital will be there. And with one atomic orbital, maximum orbitals, it is asking, I think 4 should be the correct answer now. Hopefully this is not tricking me. Oh my god. 4 is correct now. Okay, finally 4 orbitals are correct. We could have answered for the number of electrons as well. That was a good question, by the way. Even both of these questions were good, and these are tricky questions and can be asked very frequently in your exam. Be prepared, everybody. There we have the another question says that was asked in JEE 2024, 9th of the April morning shift. Question says that compare the energies of the quantum numbers of the multiple subset electron. So guys, always see that you have to apply n plus L rule. So what does n plus L rule say? Like first one is 5, second is 6, 4, 5 and 4. out of these, wherever you're getting a fixed value. So what do we see that B is the highest? B is the highest. Then among A and D, what do you see? Whatever they having n higher n value, that will be having more. Then BAD, bad. Now, where can you find the bad? Actually, it's nowhere. No, what C is saying? No, yaar, what's wrong, yaar? BA. Okay, this is BAD. I think D is the correct answer. BC, BAD, or more than that. So BAD, then we have 4, and then C, E will be having higher. C. Bad EC. Bad CE. Bad EC. C is the correct answer. See how easily we made it. Now we have the next question. Given below are two statements. Statement 1 says that the orbitals have same energy are called as degenerated. True. In hydrogen atom 3s, 3p, 3d all are not degenerated orbital. False. Since hydrogen is a single electron species and there is no electron available in 3s, 3p and 3d, all of them must belong to the same energy level. Let me check the correct answer, by the way. So second is false, first is true. Next question, everyone. The 4 quantum numbers are mentioned here, and for rubidium 37, what should be the correct set of quantum numbers? So I'll go in such a way. See, rubidium, lithium, sodium, potassium, rubidium. How do we write the electronic configuration? Helium 2s1, neon 3s1, argon 4s1, and then krypton 5s1. So this is your valence electron, and rubidium comes with 37 atomic number, minus 18. See, this is your 3 plus 8, 11 plus 8, 19 plus 18, 37. This is how it look like. Anyways, the correct answer should be what? So n is equals to 5, L is equals to 0, M equals to 0, and S could be plus minus half, whatever you want to take. Now choose the correct answer. 5, 0, 0, half. B is the correct answer. 5, 0, 0, half. B is the correct answer. All well, all set, all cool? Yeah. Next question came in 2023, 11th April, morning shift. Sorry. Number of correct statements from the following is: 1s orbital probability density is maximum at nucleus. True. 2s orbital probability density first increases to maximum, then decreases sharply to 0. No idea. Boundary surface diagrams of orbitals encloses a region of 100% probability of finding of an electron. There is nowhere you can find the 100%. This is a false statement. P and D orbitals have 1 and 2 angular node respectively, because that is what the value of L is there for P orbital. For D orbital, L is equals to 2. So this is again true. Probability density of P orbital is 0 at nucleus. True. Can I see the correct answer? 3 is the correct answer. Arey man, how many did I pick as true? Oh, 3 only then. Okay, this is 3, and this is not decreasing sharply. Decreases, then again increases. So this is false. 3 is the correct answer. See, how many 2 can you find? 3 true. Should I move aside? Reaching to the next question. A question that came on 24th of January morning shift in 2023. The magnetic moment of transition metal has been calculated 3.87. The metal ion is what? Wherever A point BC type of magnetic moment is given to you, always make sure the number of unpaired electrons, small n, will be equals to this 3. Can we find 3 unpaired electron here? Titanium, atomic number, scandium, titanium, 22. Argon, 4s0 and 3d, it will become 0, 2 plus, and then 3d 2. So unpaired electrons are 2. Then we have vanadium, scandium, titanium, vanadium, 23. Then 2 plus we are taking. So argon, 3d3, 4s0. Then we have chromium, 24. Argon, 3d, 4s0 and 3d4, isn't it? 2 plus. Then manganese manganese has 25 atomic number, 2 plus. Argon, 3d, 5, 4s0. Now if you want to find out the number of unpaired electron here, n is equals to 2, n is equals to 3, n is equals to 4, n is equals to 5 respectively. Check out the correct answer, everybody. Anyways, guys, please be focused while study, okay? And don't forget to like the session. The correct answer should be undoubtedly B. What do you think? B? The number of given orbitals have electron density along the axis. Along the axis Px, Py, Pz, all of them have along the axis, along x, y and z. Dxy planar, yz planar, and then I think 1, 2, 3, 4, 5. 5 is the correct answer. What do you think? 5 is absolutely correct. So how easy is this? There we have the another question of the day, everybody. The question was asked in JEE 2023. The question says, simply arrange the following and decreasing order of their energy. Just simply take n and l value, and we do not require any m value out of it. So it will give you n plus l values. Let us find n plus l, and let me write the values over here. So this is your n plus l values. 3 plus 0 is 3, 4 plus 0 is 4, 3 plus 1 is 4, 3 plus 2 is 5. The maximum energy is possessed by D, followed by those who are having higher value of n will be having higher energy if it comes same n plus l value. I think B should go ahead of C, and then comes A. DBCA, can you find DBCA somewhere? DBCA, yeah, D. So participate in the questions rather than judging how many people are watching, or like it should be in Hindi or what. Do not give any suggestions, anyone. We are teaching right now selflessly to every one of you, and we want all of you people, like we want this message to reach out to every one of you, and you people should solve these questions. Next question is from JEE 2022. The question is assertion and reason. Assertion says that zero orbital overlapping is an out of phase overlap. I think this is true. Then it results due to different orientations. True. What do you think? I think both are correct, and it's a correct explanation as well, isn't it? Sir, absolutely it is. The very next question is JEE 2022. Which of the following set of quantum numbers aren't allowed? Okay, I'll tell you. L should always be lesser than n. Fine. This is like -2 to +2 0 is fine. This is straight. So this is correct. 3 to -2 minus into +2. This is also allowed. 3 3. Okay, this is incorrect. The value of L is always lesser than n. So C is the correct answer. Not allowed, and this is also allowed. I won't even look at the answer, because I know whatever we are doing good. We are doing the best, we are doing the good, because we know the concept behind the question, and we have applied the correct answer here. Then we come with the next question asked in JEE 2022, and the question was asked on 30th of July. Then we have morning shift here. The number of radial nodes and total number of nodes in 4p orbital respectively are. The number of radial node and total number of node in 4p. Okay, 4p. So radial node is, this is n is equals to 4, L is equals to 1. So radial node is n minus L minus 1. Though this will be 4 minus 1 minus 1, this is equals to 2. Angular nodes are how many? Simple L is equals to 1. Total nodes are radial node plus angular node, that is equals to 2 plus 1 is equals to 3. So 2 and 3 is be the correct answer. I think A is the correct one. I think I'm going a bit fast from here, but I think that is what we need right now, that we should start solving these questions as fast as possible, because we already know the concept behind it. And if somebody doesn't, then please read out and check out my previous video where I explained all the concepts of this chapter, and then I have come up with explanation part and this practice part, solving part. Consider the following set of quantum number and then tell us how many of these are a number of correct sets are where. 3 is fine. This cannot be because L is always supposed to be lesser than N. And then this is again incorrect. This is fine. 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 This cannot be equals to this. So this is also incorrect. So I think number of correct one are 2. See how easy and how fast and how efficient we are solving these problems. We have the next question here. Everybody, let's have a look on the next question. Which of the following statement are correct? Believe me, and till here guys, we have finished 101 questions. So let's have a big round of applause, everybody. Till here we have finished 101 questions for the day. Like it took us some 4 hours, but it's okay. It's a very good speed what we are going right now in. It's 101 question and around even more than that we have solved. We have some more questions left, like some 15-20 questions. We'll finish them and then we'll wind up the session. We'll come back to those questions which we left by that time. There are 2 questions I remember. Until then, it's all fine. Let's solve these questions. Which of the following statement are correct? Electronic configuration of chromium is 3d54s1, which is true. And it's an exceptional configuration because of the more stability of more symmetric configuration 3d5. Half-filled configuration. Magnetic quantum number may have a negative value, which is true because it has the values of minus L to plus L. Then, in ground state of an atom, the orbitals are filled in increasing order of their energy. True. In ground state of an atom, orbitals are filled in increasing order of energies, obviously. Then the number of nodes are given by n minus 2. What is the meaning of this? What does it mean? Total number of nodes are given by n minus 2. But this is actually n minus L minus 2. No, it is n minus L minus 1. So only 3 are correct. What do you think? A, B and C. D. D option is the correct answer, I think. D is the correct one. Next question is with the azimuthal quantum number value for the valence electrons of gallium positive. What is gallium positive, by the way? Gallium has an atomic number of 31 with electrons of 30. Argon 4s2 3d10. See, 30. So basically this is the electron we are talking about. No. Valence means highest D. This is the valence electron. And what we are going to tell, azimuthal quantum value number. L is equals to 0. 0 is correct. Total number of orbitals with n equals to 5, m equals to positive half. What do you think? Do one thing. What I can do is, for L equals to 5, let's say L values will be 0, 1, 2, 3, 4. 1, 2, 3, 4, 5. Yeah, total number of 5 values will be there, but with the 0 to n minus 1. Now do one thing. If Lm is positive 2, so this cannot be applied, this cannot be applied. This can be applied, this can be applied, this can be applied. So one orbital, another orbital, another orbital with a value of m is equals to minus 2, minus 2, sorry, plus 2, and plus 2. Three is the correct answer, I guess. 3 is the correct answer. So how easily we have made it? Then we have, I don't think what is it, but we have done it earlier. The number of subshell associated with n equals to 4. What do you think? How many? So the number of subshells associated with n equals to 4. So guys, always remember subshells associated with n equals to 4. So L will be what? 0, 1, 2, 3. So if m is equals to minus 2, this can't be applied, this can't be applied, this can be applied, this can be applied. Answer is 2 subshells. Correct answer is 3. Now you try the next question, everybody. Please try the next question and let me grab a coffee for me. Let me try if coffee is available. Unfortunately couldn't get what I wanted. Anyways, so life is quite unpredictable. You don't get everything what you desire. Sometimes you have to think of it and you don't get it. Anyways, the number of orbitals associated with quantum number n equals to 5 and n equals to, and spin equals to positive half. So n equals to have total electron, टू एन स्क्वायर 50 प्लस हाफ माइनस हाफ 25 and minus 25, like 25 and 25. B is the correct answer. There we go with the next question. The total number of orbitals associated with the principal quantum number 5. Total number of orbitals it is asking. So actually total electrons are 2n square, and for a particular shell total orbitals will be, because we all know the one orbital acquires 2 electrons. So if 2n square are the number of electrons, then how many number of orbitals required? N square. Simple. So 5 to the power 5, 5 to the power 2 will be 25. Now moving forward to the next question, the correct set of 4 quantum number for the valence electron of rubidium. Haven't we just did it like we just made it exactly rubidium. So like Rb, it says 37 atomic number, and we know that the nearest noble gas will be krypton, 36, and then it will become what? 5s1. So for 5, n is equals to 5, L is equals to 0, m equals to 0. Spin could be positive, minus half, anything what you want. Wrong. D is the correct answer. No yaar, C is the perfect answer. Then a question that was asked in AIEEE 2012. All India Engineering Entrance Exam 2012. The electrons are identified by quantum numbers n and L and placed in the increasing order. I guess we have done it already. Now it will become a homework for all of you. We just made it. I remember. Most will be for C, and the correct answer will be C only. The only correct answer is this. Oh no man, overconfidence took me here. But anyways, let's do it. N plus L. Let us find the values of n plus L. 4 plus 1, 5. 4 plus 0, 4. 3 plus 2, 5. 3 plus 1, 4. Highest one was the 5 bit, but more value of n. The second one will definitely be C. Now B and D, value of n should be higher, B and then D. So it's ACBD, 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 B. Now we come with the next question. It says that which of the following set of quantum number represents the highest energy of an atom? What do you think? Highest energy. N should be the highest. Then n plus L, first of all, we should check. 3 plus 0, 3 plus 1, 3 plus 2, 4 plus 0, 4. N plus L highest for C. Consider the ground state of chromium. The number of electrons with the azimuthal quantum number L is equals to 1 and 2 respectively are. Okay, so let us do one thing. For the electrons with azimuthal quantum number L equals to 1. So for L is equals to 1, N should be what? When can you get L is equals to 1? S orbitals. This comes with no p orbital. P orbitals, or we can say p subshell. That sounds better. So what will be the N? 2p, 3p, and that's it. 2p and 3p. 2p and 3p. No more than that. So what do you think the electrons are? 2p. 3 orbitals are there. 3 orbitals are there. Then number of electrons will be 6 plus 6, 12. Then it is asking us that if L is equals to 2p6 and 3p6 like that. If L is equals to 2, N must be what? What we are talking about, the subshell? D. So it is like 3D. 3D has 5 electrons in it. So 3D5 has how many electrons, by the way? 12 and a 5. B. Absolutely clear. Next one is final part of this chapter. The most and final part of this chapter, most final part. Last and final part of this session. So let's see electronic configuration. So the number of radial knots in 3p orbital. So Rn has a formula of, see, 2p to 3p, just 1 will be the correct answer. That is a direct answer, but I can give you the formula also, n minus L minus 1. N is 3, for p subshell L is 1, that is equals to 1. Then we have total number of isoelectronic species from the given set. Isoelectronic species are what? Which are we having same number of electron, and that is what it has been considered under this category of the questions. Isoelectronic species will be coming. So let's see. So what we have is oxide. So let me just write the electrons. So electrons are oxide 8 plus 2, fluoride 9 plus 1, aluminum is 13, magnesium is 12 minus 2, 11 minus 1, O positive is 8 minus 1, 7, magnesium is 12, aluminum 3 plus is 13 minus 3, and fluorine is 9. Now check out the number of species with same electron. 1, 2, 3, 4, 5. Five is correct. So outermost electronic configuration of 4 elements are given like this: 3s2, 3s2, 3p1, blah 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 blah. The ionization energy. Oh my God, this is not a part of our this chapter, but this will be particularly dealt with the very next chapter, that is modern periodic table and periodic classification of element. But anyways, we can try this question. And how can we try this question, by the way? 3s2, 3s2, 3p1. So I think this is the stable configuration right now we are having, and apart from this, this is also stable configuration. This one is a stable configuration. I think C might be having the highest value of the ionization enthalpy. Right, everyone? So we are right now on the edge to finish this whole lecture, and this was about the electronic configuration, although we have not covered this part of ionization potential. So we'll take, just let me just write it by my own only, for my own satisfaction. C will be the nitrogen, sorry, 3p3 is there, that will be phosphorus with the highest, and then comes your p4, D, then comes your A, and then comes B. This is the ionization energy one. But anyways, when you people will be coming to this chapter, then you will come to know that how I have assigned these values and what is the particular way, okay, of analyzing these things. The pair in which ions are isoelectronic with Al3 plus. First of all, let us know how many electrons are there with this. 13 minus 3 is equals to 10. So how many can you see? Bromide cannot be the one. Beryllium can neither be the one. Cl minus Li plus is wrong, because Li plus has how many electrons? Hydrogen, helium, lithium. Then it will have 2 electrons only. And then sulfide is 16 plus 2. Potassium is 19 minus 1. But still not isoelectronic there. And oxide 8 plus 2. And magnesium 12 minus 2. And this is also having 10. I think D is the correct answer. This is not. Then we have next question. JEE in 2021. This question was asked in. Outermost electronic configuration of group 13 is given to us. 4s2 4p1. The electronic configuration of an element of p block, period 5, placed diagonally to an element E is what? This is some good question, by the way. First of all, we must know what is 4s2 4p1. 4s2 4p1 is who? 4s2 3d10 4p1 is your gallium. Then we have to sit diagonally opposite, period 5. You have carbon, silicon, germanium, tin, lead. This is talking about tin, actually lead here. So this is 32. 32 plus 18. 18. 50 might be talking about tin. What do you think? So gallium has 4s2 4p1, and Sn might be having what? Nearest gas, krypton, not krypton, 5s2, 4d10, 5p2. Check out everyone. I think D is the correct answer. See, krypton 4D 5s 5p. D is the correct answer here. Perfect. Then we have hydrogen has 3 isotopes A, B and C, and the number of neutron in A, B and C respectively are. So 1H1, 1H2, 1H3. This is called as, so electrons are 1, 1, 1, protons 1, 1, 1, neutrons Z, A minus Z, 0, 1 and 2. So 0, 1 plus 2 will be what? 3. And I think that's it. The group of having isoelectronic species, oxide, fluoride, sodium, this is correct. Pick out the isoelectronic species. The carbon is 12 plus 3 minus 1. So this is 14. H3 plus is 3 plus 16 minus 1 is 18. Then nitrogen is what? 7 plus 3 is equals to 10. And then 12 plus 3 plus 1 is 16. None of them are having here. Let me just recheck it. Okay, I made a mistake here. This is 3 plus 8 minus 1. So 10. I think second and third are the correct answer. And even fourth one also. Mistakenly, here also 6 plus 3 minus 1. These three are having the same. So that's it, everybody. There we are ending this chapter. Thank you so much. And I hope you all have enjoyed the session. And if yes, then please like the session. And I remember there were like 2 questions which we left. And I would like to give that question to you people as a homework. And probably in one of my next lecture or one of the very next session, I'll explain those questions. So right now we are running out of time, and we have been asked to shut down the system here because of some urgent issue which is going on over here. So I will have to leave right now, but I'll come back next time and we'll have some more amazing sessions like this. And believe me, whatever the question was there, I'll introduce them in one of my very special video, and we'll let you know the answers very soon. And comment me about those 2 questions and post your solution over there. Try to give me the idea how can we approach to those 2 questions. Which 2 questions I'm talking about? The one of the question which is related to the luminous intensity in candela. The another question was a question that was belonging to the required energy, maximum kinetic energy, and some absorbed energy. There was a relation between them, and the answer given was a 2, and that was an integer type question. So anyways, we'll meet up in the next class. Until then, take care everybody, and love you all, and we'll connect you very soon in my next lecture. Thank you for this amazing session.